Discovery, go at throttle up. Discovery, go at throttle up.
Okay, no more starting screen. There you go. Here, we could just sit here while I'm warming up. There you go, Rigaro. You good? Why do you do this? I don't know. Yeah, Hellfish, that'd be nice. That'd be nice. Have you seen the Formula E track in London? No, someone. I don't bother finding the location of porta potties. I just try to find a real bathroom. Formula E is terrible. Before you go, well, I'm just messing with you. I'm just messing with you. I'm just messing with you. The mustache, dude. I got sick of it. I got sick of it. Whenever I was breathe through my nose, you feel like something. No. I was over it. I was over it, so I got rid of it. Don't worry, it'll grow back. Good news, everyone. You get the pleasure of my company tonight. I know, it can feel a bit overwhelming, but take your time. Yep. I was joking, dang. All the streamers I watch take like 5 to 10 minutes. Yeah, they also stream for like 4 hours a day. I stream for 12 hours a day. My start time is proportional to the length of the stream. Think about that, kid. Think about that. I look much younger with no mustache? Yeah, I know, dude. I know. It's like I'm looking... Like, every time I turn over to look at chat, I see the OBS window, and I'm like, who the hell is that? Oh, it's me. You know, like...
Discovery, go at throttle up.
2020, what's going on? How you been? I'm good. How are you? The mustache is pretty cool, but yeah, I was getting sick of it. It'll come back. Don't worry. It'll be back. And in greater numbers. Wait. The stash! No! It will be back, and in greater numbers. You broke your toe recently, but otherwise good. Filch. Yeah, I know. Finally, a normal human being. Oh. Come on now. Come on now. You're on your lunch break. You have another customer meeting at 1:30. Lunch. Imagine thinking EJ is normal. You probably thought I just ended the stream in anger and disgust. Nope. It's just EJ Testa. No, you made fun of me, so now I'm gonna eat pizza in front of you. This is your fault. Deal with it. Wait a minute. You're giving me crap for not folding my pizza? It's Domino's. You can't fold pan pizza. What are you, nuts? What are you, crazy? Who folds pan pizza? What's wrong with you? No, it doesn't have pineapple on it, someone. It's pepperoni. Is this like where parents fight because EJ is wrong? You're from the West Coast. What the hell do you know about pizza? I'm from the frickin' East Coast. I'm from the East Coast and frickin' Italian ethnically. What do you think? What do you think? That your Bay Area pizza is better? Oh, I'm gonna fold my pan pizza. Yeah, that explains why the West Coast is so fricked up. That explains a lot. This is illegal in Italy. You break the spaghetti. No. Oh, you break the spaghetti. No. Pepe the boop. Bro, we have East Coast pizzerias here. Yeah, and they have Japanese food in Boston, and it's terrible compared to the Japanese food in Japan. I'm sorry, but Chicago deep dish will always be my favorite. We're not talking about whether different types of pizza are good or not. We're talking about folding it. You do not fold pan pizza. Are you nuts? Oh. Oi. Tu sei un pazzo, va via da qui. Hey. See? That's what you get. That's what you get. Stay over there. Ready? Is it weird that I kind of enjoyed that? We all did. Yeah, no. We all enjoyed it on this blessed day. What is this? It's an automaton. This is Boris. Okay, that's actually pretty freaking good. I know, your boy's getting better. Hang on. I just found out I might be going to JPL for work next week, so that's exciting. Nice. Very good. Alright. We have another power stream! Menergy! We have to, I'm gonna at least try to finish that arrow shell today. Because raisins. Menergy, what's going on? Got a job interview today? Have to wear a scuba mask or something? Me? No. Oh. I was just over it. I was just over it. Felt like doing something else, that's all. Okay. Let's get my coffee and let's do this. God damn, that pizza was good. How many monitors are you running? 3. I have 2 monitors on the outsides that are attached to the streaming computer, and then a main monitor in the center that's attached to the gaming computer. This is what the middle monitor is seeing. On the right monitor, I have the dashboard on Twitch and OBS, and on the left monitor, I have Discord and the music player. And the tip alerts over there as well. And then I am also idling a couple of other streams. I have Matt open. Actually, you know what? Let's put more in there. Why not? Who else is streaming? Oh, Demon's streaming. That's cool. Yeah, I'll bring up Demon Machine. He's a mechanic that works on cars all day. And he streams working on the cars. It's cool. Dumps a little into poli-sci on his streams sometimes, though. Matt's playing GeoGuessr, though. Yeah. Do you watch the opening of the Olympics? No. It's in Japan, man. I can't watch. W, my sleep schedule's already screwed up. I don't need that screwing it up even more. With that being said, it's not that I'm watching it out of spite or not watching it out of spite or anything. I just don't have time. Time zones and stuff, man. The Rockets already screwed that up as it is, man. It only finished a couple hours ago. Tessa, I'll give you 3 guesses what I was doing a couple hours ago. Over here, it was 3 p.m. local. Sleeping. That's right. That's right. I don't get a lot of time to do that. You know, so the time that I do get to do that, I do that. I know. Novel concept. It was full of game music. The whole soundtrack was game music. Nah, neat. You know, I'm sure it was cool. No doubt in my mind. It's the Olympics, man. Olympics are cool. As someone that played a lot of track and field. And not a single Nintendo tune because Nintendo didn't license. Oh, this feels really DOS-esque. I don't know how I feel about this. I don't like this at all. Please make it stop. Wow, that was quick. There you go. Alright. Hey, Flight Sim, what's going on, man? Where is the prototype? Hey, Lovey, what's going on? Okay. Let's go. Yeah, I appreciate it, Flight Sim. Thanks, man. Alright, let's go in here. Yeah, Bazooka, I know, right? It's kind of crazy. Dude, I get a beard for a little while, and I'm just like, or a mustache or whatever, and then I'm just like, I'm over it. And I just go back to this, and then just have another one grow in. I mean, it's not like it's not gonna come back. Yeah, it's going to look exactly like this. It's an exact copy if you look at it. It's just 2 times the size. So Mother Russia filed for this patent for the Sukhoi. Checkmate, check the gray area, radar blocking material in the intake. Cool. How do you make the panel so precise? A lot of patience. Lots of patience, and that's about it. Seriously, that's about it, dude. Just a lot of patience. Okay. See this? It looks like crap. Let's try again. I didn't like how that came out last night, so. Deleted. Yep. Alright. Alright. People stand. Alright. The landing gear isn't finished, Pilch. Just, yeah. That was just for testing, dude. We can get rid of it. I just hadn't done it yet. Just hadn't done it yet, mate. Okay. I got 2 shooters, here and here. I said that I should go at this again today, because if I go at it today with a fresh mind, it'll come out better. And yeah, let's just get this part of the aeroshell done. It shouldn't take very long. But either way, guys, so this is the gigantic SSDO that we're working on. It's going to be an exact copy of this. So, like, if you look, right here, I'm using these wing strakes right here. Right? Here, I'm using a wing strake that's pretty much... See, it's just 2 times bigger. 12 hours later. Shut up. How did I get that transition to be?
Discovery, go at throttle.
Hey, Creeper. I have to make a presentation about space and its uses in my particular branch. Any keynotes, GPS. You're welcome.
Discovery, go at throttle up.
Can I fight the Ender Dragon in another end portal? But I do want. I don't know what that means, Newton. Try sentence, please. Can I fight the Ender Dragon in another end portal? But I do want to mess up the end portal by storage. Nope. Try again. I'm not sure what you're trying to ask. MC 18-month resub. Motorkid 64-month resub. Oh no, what happened? Just over it. That's all. It happens. Why use more word when few do trick? I'm trying, Chief. Trying to please everybody. I'm trying, Ace. Interesting. Why isn't that lining up? Something is not... I'm starting to think that something ain't right here. Oh, that dang old boy ain't right, man. I mean, dare I do this? We were talking about bending this stuff yesterday. Nope. Start over. Nope. Okay, that right there is where that has to be, but I'll leave that there for a second. Maybe use a dummy piece on the original to determine the absolute angle. Make, I'm starting to think that I don't have these correctly positioned, so maybe we start working on the front arrow shell here and see what it does. Mr. J Speed, sorry, I'm still waking up, man. I need more coffee. Dude, you have the same color name. You have the same icons next to your dang name. So at quick glance, I'm like, ah! Damn it, man! Nope, don't change the color either. That's on me, not you. Yeah, there's Mr. J-Speed, there's Mate, there's Mr. Drummer. You guys are all confusing me, man! I got Gamecast. Well, there's GameCube, and then there's Dreamcast. Oh, shut up, man! I can't afford it! Just be happy he didn't call you Element. Or I'm different. Okay. Alright, let's save this. And we'll work on the front, I think. I think I may have starshipped this and made that nose cone a little too pointy. But yeah. I got my dad's spear gat. I got this from my Uncle Hamed. You have a rocket launcher. Alright. We'll start forming the aero shell here. Is that a freaking musket? That movie is a little bit on the underrated side, huh? When I say Mally, you say boo. Mally, boo! How about the part where he's like, oh yeah, Bill Gluckman. I know that guy. He's down with the B's and the O's. You know? Oh yeah, Bill Gluckman. I love that guy. Oh my god. Alright. Okay, that one's gonna go up just a wee bit. Does that smaller plane above the big plane go inside the big plane? No, Jack. That's a subscale model. So, I built a smaller one, dude, because the end game was to always build this, the big boy. This thing is huge. It's based off of Venture Star, right? So if you type in X33 into goggles, right? This pops up. The X33 was a subscale demonstrator, right? That guy is like super into it. Now they're doing wind tunnel testing there. Cool. And the X-33 was supposed to fly on a high suborbital trajectory, kind of like New Shepard or Virgin Galactic. It's like halfway in between. It launched like New Shepard and landed like Virgin Galactic, right? And this was supposed to demonstrate that you could make a wedge of cheese with some wings on the back fly correctly, right? Something that really kind of remains to be seen, right? But the X-33 was supposed to lead to a project called Venture Star. So Venture Star was supposed to be the big boy. It was the big version of it. And Venture Star, here, just look at this picture. It's like a full shuttle stack. The thing would have been frigging gigantic. It would have been righteously big. Like, that's as big as the external tank. And it would have had a payload bay about 2/3 the size of the space shuttle. You could put people in it if you wanted to. It would have been human rated, right? And it would have had 7 arrow spikes at the bottom. I'm trying to make Venture Star. That's what I'm trying to do. I'm trying to make this. Now, keep in mind, these are older concept pictures. Venture Star, in its last configuration, didn't look exactly like this. A bunch of these pictures from the program are taken at different times when they iterated on the design a little differently. So cool. Why did they cancel it? Well, it's complicated. When is it not? The first bit of problems here comes from the LH2. Tank. So, what we've been... Okay, little bit of a background here. The Venture Star was... you know how, like, people always say that, oh, you know, the Department of Defense or these defense projects are always 20, 30 years ahead of everybody else. Well, the Venture Star, let me put it to you like this. This program came about in the 90s. In the early 90s. It was a response to, it was a government program to build new launch vehicles to anticipating a much bigger launch market. The idea at the time in the mid-90s was that the internet was going to go into space. People would build gigantic satellite constellations. And this is I have a better way of explaining why the X-33 got canceled, first and foremost. Because this is just a side note here. Because a viewer in chat last night told me to go watch this YouTube channel called Event Horizon. And Event Horizon is a podcasting channel, and they had Tori Bruno on there. And actually, this was one of the questions. Not particularly pertaining to the X-33, but it was pertaining to Atlas and Delta, Atlas 5 and Delta 4. But it still pertains to the X-33. And I'll admit I'm taking some bits from Tori Bruno's explanation from the Event Horizon podcast here. So if some of this sounds familiar or sounds like you've heard it before, it's, once again, Tori Bruno, the Event Horizon podcast over on YouTube, the Event Horizon YouTube channel. So he had a much more astute way of explaining it than my other explanation. So I'm kind of changing my explanation around a little bit here, just on a side note. So if you might learn some new information here. So, okay. What was going on in the 90s was that the dot-com bubble was insane. With the adventation of the internet in 89, that changed the world. Obviously, I mean, streaming, that would come very much later, right? In the 90s, we were running, that's right. So, there was the idea that all these dot-com companies would start making satellite internet constellations, something that is just becoming a thing now, right? There was the idea that the demand for launching stuff into space would go bananas high. That coupled with the sinusoidal demand of rocket launches in general, okay? So to understand the launch market and how the launch market works, you have to understand that it's a sine wave. So what's a sine wave? If you've taken trig, right? If you haven't, an S. Just that it's an S line. It goes up and down. Demand fluctuates in the launch market. It goes up and then it goes down. And then it goes up and then it goes down. Every 5 to 10 years. Why? Why does that happen? Well, the reason that happens is because satellites have a shelf life. Straight up. There you go. Satellites only last they can only last a certain amount of time in space before they run out of monopropellant, or they run out of xenon gas, or they run out of bipropellant, and then it's just you can't keep it in the right spot anymore, and it falls out of its orbit, or it decays, or whatever. So satellites do have a shelf life. They have a consumable. A consumable is fuel, right? So in the 70s, we started launching satellites. In the 80s, we started putting stuff up like GPS, right? And then by the end of the 90s, Rule 8 people anticipated that this demand was going to come back, which it was, coupled with the commercial market for building the Iridium constellation, satellite internet, satellite TV, satellite radio, you know, all like everything was going satellites, right? So they commissioned these programs like DCX, like the Venture Star, like the X-33, right? Deadbringer, I have a time machine. Oh, I look civilized again? Thank you. Thought I might have hit on the KH series of satellites with the exception of 11. Don't talk about keyhole satellites, Creeper. Don't talk about keyhole satellites. That's way above your pay grade, homie. Don't do that. Trust me on that one. Don't do that. Don't do that. Stick to D-class stuff. You're especially OPSEC, man. Just don't talk about keyhole satellites. Don't do that. Anyway, so They were anticipating this crazy demand. So the Rule 8 people recognized this, and they started paying people like companies like Lockheed to build next generation launch vehicles that would anticipate this crazy high demand, because they thought they were going to break that sine wave of demand. They thought the commercial market would break that sine wave. It would level off and it would stay there, because you have to maintain an internet satellite constellation, right? So they thought the demand wouldn't fluctuate anymore. They thought the demand wouldn't fluctuate anymore because you always have to launch a new satellite into space if you're building a mega constellation. Gee, does this sound familiar? Demand could literally stay very linear because you have to maintain the constellation. They were anticipating this demand, okay? They were anticipating it. Hey, Livid. All public Googleable info. Be careful with that. Does this sound familiar? That guy is the freaking guy that ended up doing it, which is hilarious to me, but that's another story. So, they commissioned all these vehicles. They, heck, Atlas V, Delta IV with the EELV program, they were built to work. This is why Tory Bruno all of a sudden can just crap out like 5 Atlas Vs and a Delta IV Heavy just shows up somewhere. That's how. Because Atlas and Delta were built to anticipate demand that Falcon 9 now sees, which is funny. It's also funny because, you know, Project Kuiper with Amazon, another Blue Origin project that we haven't even talked about, which is Amazon's internet satellite constellation, it ended up purchasing Atlas launches for what Atlas was originally intended to do. Launch on a very high frequency. Delta IV and Atlas were designed to launch a lot, and so was VentureStar, and there's a couple of other. There's a couple of ones. There's the X-34, the X-37. All these projects came out of anticipating that crazy high demand that was going to happen. And then, in 1997, the dot-com bubble burst. There was a massive recession in 97. The millions of dollars at the time that were going to go towards this stuff just dried up. Now, don't get me wrong, the government funding didn't dry up. They kept doing it a little bit longer because they thought it would just bounce right back, but it never did. Not until about 5 years ago. Yeah. That's what I mean when I said it sucked to be a space fan in the 2000s. It was really annoying. Nobody cared. But anyway, so VentureStar, they didn't cancel it right away, okay? They didn't cancel it right away. It kept going into the late 90s. The program kept going. Then they had a problem with the liquid hydrogen tank. Now, specifically talking more about VentureStar, okay? VentureStar, this goes back to me, talking about how defense projects are way ahead of their time. You know, everybody goes around and says that stuff like, oh, you know, defense projects are 20 years ahead of what we know right now. And that ain't wrong. Because if you look at the VentureStar, man, this thing is insane. It is insane for what it is. All right? Now, why? Well, what do you mean? Okay, it just looks like a bunch of teardrop-shaped tanks. What's so hard about that? Well, the VentureStar, just like every other lifting body in existence, Space Shuttle, X-37, Dream Chaser, has a little bit of a problem. You have rocket engines hanging off the back of your flying vehicle. When you have rocket engines hanging off the back of your flying vehicle, it turns out that it ends up being very aerodynamically unstable. Not technically. You need a blunt surface, a flat surface to mount a rocket engine, for the most part. Like the shuttle, or like this. So the fact that they had this big old heavy engine in the back, now keep in mind, it's one engine. That's an aerospike engine right there. We can talk more about that in a second. All right? Because you have that up there means you have to shoehorn all the mass into the front to get your center of mass balanced so the thing flies correctly. Now, with the Space Shuttle, they didn't have to worry about that too much because the Space Shuttle has a big old hollow payload bay in the center. Okay? So, you need the center of mass of the shuttle to be right around here. Right there is good for the Space Shuttle because that's right around the center of lift, it's right around the landing gear, etc., etc. The way that NASA came up with to balance out the fact that they have 3 Mack trucks worth of engines sitting on the back of the orbiter, which rearward center of mass on planes does not fly very well. I.e., it doesn't. It flies about as good as Falcon 9. Generally, with a plane, you want your center of mass up in the front. That's why, you know, World War II planes have the engines up in front, because it's more stable that way, right? The shuttle has a rearward center of mass bias. How NASA or Rockwell engineers came up with the idea to fix that problem is shoehorn as much as you can into the nose. The nose of the shuttle would have as many things as you could put up at the front, you put up at the front. Like where the people stay, for instance. The crew tank where the people stay. All the avionics are up there. The water tanks for the crew, potable water, all up at the front. As far forward as you can go. Even they went even so far as shoehorning the landing gear into the front, because even though it's a smaller landing gear up there, it still has more moment over the center of mass. Or still has more moment over the engines. Because it's all the way at the freaking front. All the forward RCS, shoehorn that as much as you can into the nose. If you look at the nose of a space shuttle in like a cross section, it is built like stacked bricks in there. There's not much space for anything in there. You have your forward RCS here. Underneath that, you have the front landing gear. You need the nose cone out in the front. That's important. The shuttle has the avionics bay right there. Lockers and storage right in front of that. And so if you need to get at the shuttle's flight computers, you could pull the lockers out. They had to do that during STS-1 on a side note. They have all the controls, all the manipulator controls, payload bay controls, everything. The bathroom, the airlock, the kitchen, everything is at the front. And then a lot of people don't know the shuttle has a third deck underneath here. That's where they put the water tanks and other storage. There's 3 decks to the shuttle. There's the flight deck, mid deck, and third deck. So that's how they solved that with the shuttle. Now, like I said, the shuttle has the benefit of having a gigantic freaking payload bay that's mostly hollow, so you can balance it. If you notice here, if you look at this picture one more time, right? Center of mass, because the landing gear is pretty much right here. You know that the center of mass is in front of the landing gear. The center of mass on the shuttle is like right here. Right? Because if it wasn't, when the shuttle went to land, it would just tail slide down the runway. So if you just kind of stare at and look at this picture for a second here, okay? If you look at the distance between the center of mass and the engines and the center of mass and the flight deck, where all the stuff is that they shoehorned into the shuttle, you notice it's about 2 times the distance away. Right? The flight deck and everything is 2 times the distance from the engines. You know what that tells me? That this weighs half as much as the engines do. Because if you have this 2 times the distance away from the engines, and the engines weigh, let's just say the engines weigh like 40 tons, right? This weighs 20 tons, double the distance away, you have it equalizes out. It's like a lever, right? It's a lever. That's how they fixed that. Not fixed it. That's how they made that work with the shuttle, okay? It's a big and hollow in the center. Now, going back over to Venture Star over here, right? Going back over to Venture Star, you don't have, the payload bay is here. So you do have a hollow payload bay in the center, but you still have to counterbalance your big engine. And there's no big payload bay to solve that problem, because where the payload bay would be, you need fuel because it's an SSTO. Nothing flies off. On the shuttle, the boosters separate. The orange tank separates. Right? This thing just flies into space. You hit the go button, up into space. No problem. So you have a mass balance problem, okay? What the Lockheed engineers came up with is, long story short, try to make the hydrogen tanks as light as humanly possible. Hydrogen is also is pretty light, but you need about double the volume of hydrogen. Actually, no, it's more like triple the volume of hydrogen to oxygen to get the Hydrolox engine to work correctly, just on a side note. So you need to carry a lot of hydrogen, and you need the center to be relatively light. Okay? Because you need that counterbalance thing going on, like I said. So, this is what I mean when I say this is cutting edge. Well, so, the tanks on the Venture Star are carbon composite tanks. They're composite, which is carbon fiber tanks in the 90s. Okay. These things. Carbon fiber tanks. Carbon fiber Hydrolox tanks. Nobody's done that. Nobody's done that. Nobody's done that since. When did they add the drag chute to the shuttle? In the 90s, T-Men? Pretty much after Challenger, because they figured out that the shuttle's brakes were getting cooked during landing. Would you say some of this dictated the length of the cargo bay? Well, J-Speed, yes and no. The keyhole satellites dictated the length of the cargo bay, and the shuttle doesn't necessarily have everything shoehorned into the front. Some of it is underneath the payload bay to help balance out the design. It was more the Air Force saying, we need a 15 by 45 foot payload bay, and NASA going, why do you need a payload bay that big? And the Air Force basically said, that's none of your business. It ain't any of your business why we need the payload bay that big. You need to make that payload bay that big if you want to see our money towards this launch vehicle. Why is the Canada arm on the front of the shuttle and not on the back? Because you control it from the front, not the back. No, it's to launch spy satellites, guys. The shuttle's payload bay perfectly fits a spy satellite in it. Jeez. Ever wonder why Hubble fits so well in there? The Hubble is a highly, highly, highly modified spy satellite pointed in the wrong direction. Seriously, it's not a spy satellite. They had to redo a lot of things. I've said that in the past as a joke, but people take it literally. Yeah, the Hubble is a spy satellite pointed the other way. But anyway, going back to the carbon tanks, you had to make these out of carbon fiber to make them light. So that's what they did with VentureStar to help that counterbalance design. Okay, so you have that big heavy rocket engine up here, and you have the really, really light hydrogen tanks in the center, and then you have an aluminum liquid oxygen bilobe tank up front. They made this one out of aluminum, and they made this one out of carbon fiber to try and solve that same balancing problem. Because a hypersonic reentry vehicle, physics doesn't change. You still have to solve that problem. Unless you want rockets up at the front of your rocket, which is pendulum fallacy, which is not really a good way to do things, right? So, they had to come up with ways to lighten it. Now, the carbon composite tanks were light years ahead of their time. Like I said, the only people that have done carbon composite tanks and actually made it work is Rocket Lab, and that was only in the last 5 years. And they weren't even trying to make that shape right there. The reason why they made these bilobe tanks is to try and get the tanks to fit into that, well, cheese-shaped shape for VentureStar. So the tanks were, I'm telling you, they were cutting edge for the time. Now, remember how I said a second ago the demand crashed. There was no demand for this, but VentureStar kept going past 97, right? And then they were doing tests on the tank under load with hydrogen inside or liquid nitrogen, like what we saw SpaceX do, right? Remember, we saw SpaceX push stuff to failure and it blows up, right? With the liquid nitrogen. They were basically doing that with these tanks, and the tank seams popped. They had fractures in the carbon fiber, and they had a test fail, basically. And the test failing was a convenient out for people to say, oh, that's not going to work, let's not do this. So the Rule 8 people stopped funding it. It got Rule 8'd pretty badly. Like the shuttle, like everything else. The politicians, because there was no demand for the launch market anymore, right? And there's no demand for it anymore, so they said, they tried to save it. I mean, the politicians tried to save it, but people said, look, there's no demand for the launch market anymore. We don't need this. So let's not, we need to spend money on what I want to spend money on, right? Because that's how politicians work, right? So they canned the program. They canned it. The prototype was 97% complete. And like $900 million invested or something? $900 million. So annoying. For the lobe tank, is there a bulkhead at the points where the two cylinders join? Yeah, dude. Oh yeah, hip. There's stringers inside of it. Yeah. Oh yeah. How are you gonna pressurize that? Yeah, that's why they had problems. There's a crisscross inside of the tank that connects the lobes together. So the top lobe is like this. Hey. Yeah, right. Top lobe is like this. There's a huge structural frame that goes like this, and it X's through it. I'm guessing thick insulation. Well, T-Man, that's pretty astute because, here. We can find tests from the tank. Look at the tank. It's got spray-on foam insulation on it. Well, that's the liquid oxygen tank, to be honest with you. That's the LOX bilobe tank. That's not the hydrogen tank. But yeah, check it out. They had a internal stringers. There's the stringer design right there. There was structure connecting the lobes together. So basically, Rule 8 people use that as fodder to cancel the program. But it wasn't some crazy conspiracy, to be honest with you. They canceled the program because the demand went in the crapper. The demand for rockets crashed so hard that Lockheed Martin and Boeing, now Boeing and McDonnell Douglas, were literally going to pull out of the program. They were going to say, in the 90s, they were like, why should we even bother? This is a waste of time. We're never going to get our profits back. We just invested billions of dollars into developing these vehicles that can be rapidly launched, right? And we're never going to see the return on that, not for years. So screw this. Why are we doing this? And the government said, no, you are going to keep building your rockets and you're going to like it. And Boeing and Lockheed said, no, we're not. Pay us, please. And the government said, all right, fine. No. You and you work together, and we'll pay you to keep the pads working because we want to launch spy satellites or defense satellites or whatever into space. So the launch industry crashed so hard, they had to do they literally went to everything but nationalizing the launch program, the launch vehicle program. The Evolved Expendable Launch Vehicle Program, EELV, is part of the reason why ULA exists. That's how hard the launch market took a dump in the 90s and the 2000s. It was, I'm telling you, man, the 2000s were a terrible time to be a space space fan. The only thing good that came out of it was the ISS. Yeah, they also got caught spying on each other, but that's another story. So the government basically said, we'll pay you to make a new company, just launch Atlas V, just launch Delta IV, and go from there. And that's how ULA got made. That's how ULA was basically a consolidation of the launch market after the launch market took a dump in the 90s. That's what happened. That's why ULA existed in the first place. Now, it's important to understand with ULA that the government, for the longest time, because there was nobody else building rockets, the government paid them to keep their launch pads operational, even during years where they didn't need to launch anything into space. Because remember, the launch market went back to being sinusoidal again. It didn't go linear like they thought it was going to do because of the dot-com bubble. So they paid them, and that's how ULA, that's how bad the launch market got. They basically had to say, no, you're not pulling out of this because we need to launch spy satellites into space. You're going to make a company, and we're going to pay you to launch stuff into space. And Boeing and Lockheed said, all right, whatever. So they spun it off. They spun off their launch vehicle divisions into ULA. And ULA has a contract for the shuttle? No. The shuttle was operated by a contract. Actually, the shuttle was a contractor. It was a commercial contractor operating for NASA. Yeah, the shuttle was operated by a company called United Space Alliance, USA. Mm-hmm. Yeah, MGB, that's right. Yeah, a guy that ran the EELV program when it started in the 90s, all the way until 2016. Well, not till 2016, but a guy that ran the EELV program was a colonel in the Air Force, Colonel John Insprucker. John ran the EELV program. You know, SpaceX, John Insprucker here. We're returning pad 39A to interplanetary flight. That guy? Yeah, that guy is responsible for Atlas and Delta existing. Yeah, you're welcome. Yep. Go look it up, dude. Seriously, he ran the EELV program. Yeah, and before that he worked on Titan, which was the predecessor to the EELV program. Yep. I don't think John Insprucker ever worked with Tory Bruno Torrey Bruno was an engineer at Lockheed. Torrey Bruno was not in the launch vehicle business per se. Torrey Bruno is a defense engineer. Missiles and ICBMs. That's where he comes from. Don't get me wrong. He worked on all kinds of stuff. I mean, you want to talk about people that Torrey Bruno probably knows? Kelly Johnson, Ben Rich. He probably knows. He probably knew those guys. I'm pretty sure he does. Or did. He did with Kelly Johnson. Torrey Bruno himself, this guy worked on the X-33. He worked on the X-33 program. Oh yeah, on the thermal protection system, if I'm remembering correct. I could be pulling that one out of my tail. Does that guy deserve a spot in mission control? John? I don't know, maybe. It's getting a little crowded up in here. So that's how hard the launch market crashed. And so don't get me wrong. We can sit here and say, oh, it got canceled by the government. That is the smooth brain take of that. I did 5 seconds of reading the Wikipedia article, and now I'm an expert on the X-33 program. Blah, blah, blah. Oh, the government sucks. You know those people, right? Like it's those people. No, they didn't bother us to figure out why. Rule 8 people didn't want to kill the program. In fact, they kept it going as long as they could until somebody used the tank, the hydrogen tank failing.
Discovery, go and throttle up.
Right? As fodder to cancel the program. They kept it going. They tried to keep it going. They tried to push it through, which is interesting. I am one of them. Well, now you learn. EJ gonna learn you about space. So, going back to the original question of this and this, the big one, this was always the intention to build the big one. The small one is here as a subscale demonstrator like the X-33 was. And unlike them, I'm going to push this through and we're going to get this thing finished. Stereo, 35 months, man. I come bearing TPS reports. They need to be filed by tomorrow. Oh, dear. When you go off on these teaching informative rants, it's the best content you provide. I feel like I'm watching a Discovery documentary. Good stuff. Thanks, Cryptech. I love doing those. Those are my favorite. I also like building this. It's kind of supplementary. Like, they work off of each other, I think. That's how I like to look at it. Wait for the missionmode.com crash. I mean, my rep's already in the toilet from missing too many deadlines, Steven, so it pretty much already happened. Oh, shoot. That's right, Neuro. So, yeah, this thing was way ahead of its time. Way ahead of its time. It would have been insane. I didn't even talk about the aerospike, nor did I talk about this thing's thermal protection system. The Venture Star was going to use tiles, but it wasn't going to use shuttle tiles, man. They had a design figured out for tiles that, while expensive, they were very expensive. They would have been 100% reusable. No tiles falling off. No, oh, it's going to fall off and hit something. None of that crap. The tiles for the Venture Star and the X-33 were nickel titanium alloy. They were metal tiles. They're metallic. Metallic tiles. They were metallic tiles with an Inconel box behind them. So, dude, this is some hard material science here. Check this out. So the tiles, you know, they look like regular tiles, right? Right? It's just a regular tile. And then on, first of all, they were bolt together tiles, right? They didn't glue them on. They were bolted into the chassis on the X-33, right? And then they had a box. Each tile had a little box on the back. Now, the plate, right? Nickel titanium alloy. And then the box that was on the back of this thing, that's Inconel. There's the Inconel box was placed onto the back, and then inside the Inconel box, you had aluminum cilia fibers. This type of tile is expensive to make, but you never need to replace it. They did all kinds of material science testing to get this kind of design, nickel titanium, using Inco for the back, and then using aluminum fibers. Quite literally, the inside of the tiles look like steel wool. Only it's not steel wool, it's aluminum, right? Dude, oh man, this stuff, it's so cutting edge stuff. It is ridiculous how smart this stuff is. And they ended up never doing it. And it's a shame that all this engineering got kind of consigned to the history books, because that's some hardcore engineering, dude. Here, check it out. Now, they tested the tiles. That's what this F-15B testing is. They put the tiles on one of the pylons on the X-37. There it is, right there. Nickel titanium tile. The Inconel box is behind it. The bolts are in 4 corners, and then it has aluminum cilia inside of it. And it's made by BF Goodrich. Nice. Does Starship use this technology? No. Starship uses Tough Rock. Toughen unifibrous, reinforced, oxidation resistant, corrosion resistant. Or toughen unipiece fibrous, reinforced, oxidation resistant composite. Sorry, that's it. It's like, it is derived from the shuttle tiles. The Tough Rock stuff is the tiles that the X-37 uses. The X-37 never had a tile fall off. Tough Rock is Mark II shuttle tiles. That's what this is going to use. And that's where the shuttle program could have gone. If you note, these tiles are strong enough to straight up cut through plasma by themselves. The original shuttle tiles could not do this. No. You'd need an RCC plate up at the front, MGB. These things can go right through. They'll punch a hole right through the plasma. They're really good tiles. Yeah, and also the X-37 is how awesome the shuttle program actually could have been, but that's another story. Yeah, the original tiles that were on the shuttle are silicate. They're silicate tiles, so they're rocks. It's porous rock, almost like styrofoam, like with the consistency of styrofoam. Yep. But see that, yeah, that's Tough Rock right there. See that? See this kind of, it looks like an Oreo or a Hydrox. See, that's a silicate tile right there, I think, from the shuttle. This one with the Oreo, that's Tough Rock. The shuttle tiles look much more like this, I think, if I'm remembering right. Could be incorrect on this, but either way. Oh, these are tiles. Oh no, these are tiles for Orion. Excuse me, because the picture has an Orion on it. These are silicate tiles. Let me find some Tough Rock. That's it right there. See? It looks like a sandwich cookie. That's Starship. And SpaceX is also using bolt-on tiles. What is that? Oh, Dream Chaser. Oh, okay. I was like, what? Yeah, SpaceX is using bolt-on tiles as well. The X-37 fate was decided together with the fate of the shuttle? No. No. When I say that the X-37 is what the shuttle could have been, Chief, what I mean is that they never bothered to upgrade the shuttle tiles. There wasn't enough money. They invented a new type of tile that was way better, but they never used it. The shuttle never flew with Tough Rock tiles, if I'm remembering right. The X-37B does. Okay, all right. If the shuttle doesn't need reinforced carbon, and it just has a bunch of tiles on it, well, guess what? The shuttle can lose tiles during re-entry. That's fine. It's happened before. Keep in mind, it doesn't lose tiles during the actual fiery bits of re-entry. The reason why tiles came off on the shuttle and why they fell off is because the tiles were glued on. And when you're in the fiery stuff heats the glue up, and then the shuttle comes down and lands in Florida, where there's a lot of precipitation, and the hot glue now gets water soluble, and the tiles fall off. That happened. That's part of why glue-on tiles were a stupid idea. But bolts would have really screwed you on that one. Bolts would have made them way heavier. But I mean, working, not working. I'll take less payload capacity in a vehicle that doesn't do that. They could have upgraded them with bolt-on Tough Rock tiles, like what SpaceX is doing, but they never did. They never bothered. They just said, oh, we'll just get this design to work. The analogy that I like to give with the shuttle, dude, is they were iterating hard on the shuttle up until 1986. Up until 1986, right? They were trying to really push for reuse, really push, increase the flight cadence, increase the flight cadence, increase the flight cadence, go, go, go. Upgrade stuff, do this, do that. Upgrade things on the shuttle, make it lighter, make it do more. MMUs, Shuttle Centaur, right? Like, they were really pushing with crazy good innovations, like what SpaceX did with Falcon 9, right? And then Challenger happened in 1986. And then they focused on making the shuttle safer. I understand the reasons. Don't get me wrong. If anybody's watching me for the first time here, I know why they did that. I understand. There's 7 dead astronauts, man. That's no good. I'm not going to sit here and say that they died, you know, we shouldn't have done that based off of what happened. However, we focused on making the shuttle safer. Right? And we didn't focus on making it more... Well, we did. They focused on making it more reliable, but the push wasn't there. Okay? So what does that mean? The analogy that I go with is it would be like if SpaceX, after CRS-7, froze Falcon 9's design and just tried to make Falcon 9 1.1 work the best they could. Not keep upgrading it. Move to densified propellants. Upgrade the Merlin 1Ds to the full thrust variant. And then eventually make Block 5. The shuttle never got to go to Block 5, so to speak. It never happened. They kind of froze the design after Challenger, fixed all the problems that plagued Challenger, like the SRB O-rings and stuff, and then just operated the shuttle from there. I mean, don't get me wrong, there were incremental upgrades along the way. The Block 1 SSMEs, the Block 2 SSMEs, which are those are Block 2 SSMEs right there on SLS. Really good engines, by the way. And then they upgraded a lot of stuff here and there. They put glass cockpits in the shuttle. There were upgrades to it, but it wasn't at the iterative rate that they were going at in the early parts of the shuttle program. And then by the time Columbia came around, they just said, keep operating it, make it safe enough, build the space station, and then we're going to be done with this. Constellation is the future. That ended well. Have you seen the video on YouTube about the space border that couldn't seal us on Earth? You should give it a watch. Oh. I can't believe the KSP shuttle cockpit holds only 3 Kerbals when in real life the one holds 7. Figure out a way to make it hold 7. What do I mean by that? People are going to be like, what? I don't understand, EJ. Well, EJ gonna learn you again. Remember how I talked about mass balance designs? When I made my shuttle, when I made Collins, I had to solve that same problem. So you know what I did? I shoehorned as much stuff as I possibly could into the front of this thing. So, I put a 4-person crew tank down here, enclosed inside of a fairing, that's attached on a node inside of the payload bay. And then I put all the batteries and the probe core and everything else up here at the front. I also put fuel tanks at the front for the forward RCS. And the front landing gear is as far forward as it can be. I have a mini aeroshell here, which is where I came up with the idea of making aeroshells in the first place. And I put another fairing up here on the nose cone to be able to give myself a little more room for the fuel tank and the landing gear to shoehorn it forward. See? My shuttle cockpit holds 7. Actually, it can hold 8 if you put somebody in the airlock. What? There's nothing down here anyway. You might as well. The shuttle Mark III cockpit is too light. It's way too light. If you're building a shuttle, that's not enough. One of the vectors weighs 4,000 kilos, guys. One of the vector engines is 4,000 kilos. You have 3 of them back there. And you're telling me this thing is 3.5 tons. You add a couple of Kerbals. You add 4 Kerbals in a spacesuit, right? And that gets to maybe 4,200 kilos. There's no way that's going to counterbalance that. That's the original idea how I came up with the aeroshell. I decided to put panels up here and node attach them to help weigh the nose down to get my shuttle to work right. How do you get fairings to clip? build it outside and then just move it in, Regaro with the tweakables. What is the history of reaction control systems? In general? In general, Acidio? Or what do you mean? Yeah, there you go, Penta. Take it with a gigantic grain of salt. Falcon Heavy has got the contract for the Europa Clipper. Yeah, I will take that with a grain of salt, but I believe it. Yeah, in general, reaction control systems were something that they knew that they would need from the start, dude. There are a couple of different types of reaction control systems, I mean, that are generally used. Don't get me wrong, there's 1,000 different ways to make a good RCS. So, we'll take the shuttle, for instance, Acidio. The shuttle is using monomethylhydrazine and dinitrogen tetroxide for its monopropellant thrusters. It's RCS, its monoprop thrusters are not monoprop at all. They're little tiny rocket engines. Was Collins the same length as the real shuttle? Pilch, it's 2 scale. Kerbal scale is about 66% of real life scale. Why? Because a Kerbal is 2/3 the height of a human. And that's not from me, that's not me guessing. I have that right from the developers. So this is a 2 scale shuttle. It's about 2/3 the size of the real one. It is scaled correctly to the Kerbals. Dude, I'm obsessed with scale. I think scale is really, really important. This is a 2 scale shuttle. So if I stood next to this thing, the shuttle would look small. If I tried to stand up in the flight deck, it would be too small. I'm a Kerbal. If you want to use it, if you want to use a good rule of thumb for like measuring stuff, a Kerbal with their spacesuit on is about the size of one of these fuel tanks. That's about the size of a Kerbal. So a Kerbal would fit on the flight deck of this shuttle. A human, or average human, is that tall. The I-beam is the rule of thumb there. See what I'm talking about? So it's 2 scale for Kerbals. If I tried to stand in here, I would not have enough room. I'd be like this. But then again, I am like that in the shuttle payload, on the shuttle's flight deck anyway. I've stood on the, I've been inside the shuttle trainer at the Museum of Flight. I've been inside of it, which it's got a fully, it's not fully functioning, but it's a full scale flight deck. It's not functioning anymore, but hey, Alex, what's going on? But where is Grissom? So the shuttle's RCS is bipropellant. It is liquid fuel and oxidizer. There's three kind of places for RCS on the shuttle. There's the forward component. There's the aft port and aft starboard components there in the ohms pods. So there's all different types of monopropellant types of RCS. This is a bipropellant. This is generally what you see the most of. You see the most of a bipropellant hypergol thruster like that. That's what was on Apollo. That's what's on the shuttle. That's what's on Orion. That's what's on Starliner. That's what's on Dragon. They all use monomethylhydrazine and nitrogen tetroxide. The reason why they do that, Acidio, is because monomethylhydrazine and dinitrogen tetroxide are they're super toxic for humans. First of all, very carcinogenic. But they are also, they can be stored for long periods of time. They don't break down. If you ever, I mean, propellants usually boil off or they break down. You can't store Kerolox in space for an extremely long period of time. If you do, the kerosene will break down. Just like gasoline breaks down into varnish. It happens. So monomethylhydrazine and dinitrogen tetroxide you can store up there indefinitely. They're liquids at room temperature, and you can also be afforded a you're also afforded a rocket engine that is very, very simple. You're afforded a rocket engine that is super simple because monomethylhydrazine and dinitrogen tetroxide, when they touch each other, they explode. When they chemically combined, the chemical combination there literally makes an explosion. Yeah, it's called hypergolic. Hypergolic stuff explodes on contact. You ever see like Die Hard 3? Remember it's a binary liquid. That's kind of like that. Alex, you officially finished your 6-week-long rocket engineering internship. I had a great talk with my supervisor who revealed I had exceeded expectations. I'm happy. See, man? Push through, dude. I told you. Yeah, that's awesome, Alex. Push through, bro. If it was easy to do, it wouldn't... If it was an easy thing to achieve, everybody would do it, man. You know, when the going gets tough, just keep pushing through. If you're going through hell, keep going. You'll get out eventually. Right? Hell yeah, man. That's awesome. Yeah, hypergulls are bad for you. Hypergulls will kill you instantly. Yeah, don't breathe it. Don't breathe it. It's carcinogenic. It'll just basically make your lungs not lung anymore. Thanks a lot for the pep talk. Seriously. Help. Well, if you're going through hell, keep going. I think Patton said that, if I'm remembering right. So that's RCS on like the shuttle. That's a bipropellant RCS. There's monopropellant RCS too, and monopropellant RCS is a little bit different. There's two types of monopropellant RCS. So there's something like what Falcon 9 has, where Falcon 9 basically has an N2 tank, right? And the N2 tank basically goes to a thruster, right? And then they have a solenoid on it, an electronic switch that opens and closes the valve, and psh, psh. And all you're doing is using the pressure of the tank, the pressure inside of the tank to psh, to spray the thruster, right? That's just a straight pressure fed attitude control system, or RCS. There's also another type. This one's cool. There is another type of monopropellant thruster that uses MMH, hydrazine, so the liquid fuel, but it uses MMH as a, I think it's called Aerozine 50, is what they used to call it. I don't know what it's called now. They use MMH inside of a tank, and then they have that going to a rocket, and the rocket engine looks like this, right? Or the little thruster. In here is what's called a catalyst, right? And you can actually take this thruster, and this one can be pressure fed as well if you want it to. So basically, there's a solenoid right here that opens and closes, right? And when it opens, the hydrazine hits the catalyst in here, which looks kind of like just a screen. It looks like a mesh almost. When the hydrazine hits the catalyst heats the hydrazine. There's a chemical reaction, and the catalyst heats the hydrazine, and then the heat expansion creates. Pretty cool, huh? A lot of satellites use this because monopropellant. Now, why would you do this? You do this because it's ridiculously simple, and if you need a little bit more pop from the thermal expansion, as opposed to the nitrogen thruster, which is just a cold gas thruster, this gives you a little bit better specific impulse. The nitrogen thrusters don't give you a lot. That's not good specific impulse. Just literally letting air out of or nitrogen out of a tube, you don't get good impulse from that. This gets a little better impulse, and it's a little more complicated, but it works. And then there's the other one that I said. This is the one that's on the shuttle. And then you have two solenoids that open and close here. And then when they hit in here, and they hit in the combustion chamber, the rocket engine turns on. That's a bipropellant, monopropellant, or bipropellant RCS. That's a lot. Most stuff uses that up in space. I think I covered all of them. So there's Aerozine 50, which is monopropellant catalyst. There's cold gas thrusters like nitrogen, which is just a pressure-fed attitude control system. There's bipropellant attitude control systems or reaction control systems, like what the shuttle uses. Is there any more? There's hot gas thrusters, which is just basically what the nitrogen thing is. It's the same thing as the one with the nitrogen, only it's using gaseous methane, and the gas is hot instead of cold. Elon said the same thing, going through hell. Yep. I think I got all of them. Now, yeah, but all these different designs, all these different designs have been used at different points in history. I forget which one came first, to be 100% honest with you. I'm pretty sure the cold gas thrusters were the first ones. They sent Ed White outside of the Gemini spacecraft when he did his EVA. They sent him out with basically a can that's a reaction control system that's more similar to the thing that you use to blow out a keyboard. You know, the can of compressed air. Yeah, they literally sent him out with a can of compressed air and said, all right, go out there. Here, this is your RCS. Like Wally with the fire extinguisher. Yeah. Literally that. They did that. I mean, the funny thing is that Alexei Leonov, when he did his EVA, the Soviets did the same thing. They're like, he's like, how do I maneuver? How do I go in space? They're like, here, have compressed air. It's good for you. How goes the build today? Good, good. Yeah, there's solar electric propulsion, too, which is, yeah, SEP. SEP can be used for reaction control systems, I suppose. Solar electric propulsion is basically when you have a combustion chamber that has 2 electrodes in it, and there's a pump that puts inert gas inside of that combustion chamber, and then they arc electricity through the inert gas, and the gas ionizes using the Hall effect, and that does create thrust. Ion thrusters are about the highest impulse that you can get from any thruster around. They are the most efficient. They don't need a lot of inert gas to create a Hall effect to create thrust. The problem is that if you have a fan on your desk, a little tiny fan about this big, that probably has about 80 times the thrust of an ion thruster. They have very low TWR. Yeah, the TWR is very low because they're solar powered. If we, for instance, had a nuclear reactor in space that's generating electricity, then you can scale ion thrusters up to have more TWR. But once again, me doing this has more thrust than an ion thruster. Yeah, it's really, the constraint is electrical power generation in space. And while solar panels are way more efficient up there, because it's getting direct light from the sun as opposed to diffused light through the atmosphere like down here, they still don't generate a lot of power. If we had a way to generate more power, we could definitely pump more gas, and you can scale ion engines. They can be scaled. There is a company in Massachusetts that's near Framingham, where I worked at Best Buy, that makes the ion thrusters for Gateway. And I had a guy come in here one time, and he's like, oh, bro, you know, I live right near you, and I work on ion thrusters. I don't know if that guy still watches the stream. But I asked him. I was like, that was the first thing I asked him. I'm like, is it scalable? And he said, oh, yeah, it's scalable. Oh, yeah, it is. So, like, for instance, if we had a NERVA, a nuclear thermal rocket, right? If you had NERVA, and the nuclear thermal propulsion is a nuclear reactor that's sitting inside of a rocket engine, and they cool the reactor, instead of like a coolant loop and a big cooling tower, you can't do that in space, they pump liquid hydrogen through the reactor, and the reactor heats that liquid hydrogen similar to the catalyst monopropellant system. The nuclear reactor heats the hydrogen, and the hydrogen is very conductive of heat. Yeah, it expands a lot when it heats up. And that's what the nuclear thermal rocket engine is. They're flowing liquid hydrogen over a nuclear reactor inside of a rocket combustion chamber, and the hydrogen heats up, and it heats up so much that it creates thrust. A lot of thrust, actually. It creates a lot of thrust at like 1,000-second specific impulse. It's like twice as efficient as the most efficient rockets we have flying today. The one exception is ion propulsion. But if you had a nuclear reactor, if you had a nuclear thermal rocket, it's still a nuclear reactor. When you turn the engine on, you're technically, you're cooling the reactor. The reactor is on. How you throttle a NERVA engine, guys, is controlling the control rods like on a nuclear power plant. It's very similar, actually. And when you open the control rods, the nuclear materials, they're unmoderated and they have more radioactive flux. Basically, they generate more heat. And if you put the hydrogen over that, you can make thrust, but you can also generate electricity with that heat. So in the future, guys, we could have something like Starship, right? And I know there was a YouTube video about this the other day, but you could have something like Starship with nuclear propulsion in the back and a nuclear reactor inside, and you could have solar electric propulsion, RCS. The only two consumables in this thing are xenon gas, which solar electric propulsion is extraordinarily efficient, so you would never run out of that in something as big as Starship. You just have a tank that's the size of one of their COPVs. You would run out eventually, but it would take a while. And the electrical power generation for that could be done by the nuclear thermal rocket. You could turn the nuclear reactor on and generate electricity and not make enough thrust to fill up the combustion chamber. So you could generate power with the nuke, right? And you can also you can have ion RCS. That is not something that is like, oh, that's a sci-fi design, EJ. They'll never do that. No, that's totally doable. The only thing is that we got to find a way to put a nuclear reactor up there or a NERVA engine. But NASA restarted the NERVA program in 2018, so we're getting there. And the Russians did too, which is even cooler. The upper limit is at about 2,000 for classic nuclear thermal. 2,000. I mean, Alex, even that 2,000 second specific impulse, dude. Frick transfer windows. You don't need to worry about transfer windows when you have 2,000 second specific impulse. Nah, that's not a thing. Tinfoil hat moment, but we might get a certain contract from NASA at 4 p.m. Eastern. I heard about that. Yeah, interesting. Russia's working more on plasma engines now for Nuclon. I mean, a plasma engine, same result. Same result, different way of doing it. But yeah, dude, guys, if we, and this is more for the newer viewers that don't know me, all right? For the regular viewers, you guys have probably heard me say this before. Nuclear thermal engines, you want humans going around exploring the solar system like we do in The Expanse and stuff, that flip and burn stuff, we're flipping now, cowboy. That kind of stuff, nuclear engines will achieve that. Not as fast as an Epstein drive from The Expanse, but almost. It's almost there. That nuclear thermal propulsion is straight up sci-fi. That is straight up sci-fi vehicles in real life. Taking dry mass versus specific impulse into account, solar electric is more efficient up to Jovian Saturn orbit. Past that distance, nuclear electric wins. Nuclear thermal is not much more mass efficient and loses quite a lot of specific impulse to ion thrusters. Yeah, so Kamer, I understand that, but technically Beresheet is way more efficient than the Apollo CSM getting to the moon, right? But you got to remember that one of those things needs to move humans around, and humans need consumables. So time is of the essence, not necessarily efficiency, right? Wait, who replaced EJ? Babby EJ. Read a book called Saturn Run recently. Plot I won't spoil, but the ship uses Vasmir, which famously has waste heat problems. In the book, they use the heat to melt a metal alloy that they then extrude into space and let it cool. Then retract it back into the craft to be reheated later. Super detailed description too in the book. Huh. Nice, Graph Shark. I love good, solid sci-fi. Well thought out sci-fi is sick. That's why The Expanse is so good, man. In The Expanse, the rockets are pellet fusion or something. Fusion rockets are not impossible. They're not impossible. They're doable. The Epstein drive can be made in real life. You just have to figure out how that whole fusion thing. It's possible. Fusion occurs in physics all the time. There's this big thing that comes up over the horizon every morning that makes everything nice and light out. And if you stand in it for too long, you get burned. Fusion does happen. Fusion exists. We just haven't figured out a good way to sustain it. That's all. Menergy! No, just meme title. Magnetic containment fusion drives are possible, Graph Shark. That's totally doable. I do not see a reason, and keep in mind, I'm just some bum that reads about it for fun. I don't see any particular thing other than sustaining a fusion reaction. That's the big one. I don't see any reason why a magnetic containment fusion engine couldn't work. So, what's a magnetic containment fusion engine? So, the whole thing with fusion is what you're trying to do is create plasma. You need to make plasma with fusion. So, splitting the atom, right? Or fusing the atom creates an insane amount of energy. More than splitting the atom. Splitting atoms makes a lot of energy too. We figured that one out in 1945, for better or for worse. Fusing them makes infinitely more energy. That's what the sun does. The sun fuses the atoms, but it uses its crazy gravitational pull to fuse atoms together, fuse hydrogen together, believe it or not. And that's why the sun radiates out all this crazy energy, right? Because that's what it's doing. It's fusing atoms together. So we can do it, right? But in a fusion reactor, when you fuse atoms, right, part of the byproduct is ionization. They ionize, like similar to the phenomenon that happens when something re-enters. Same thing. You want to make plasma, and that plasma makes a lot of heat. Basically, a fusion reactor or a magnetic containment reactor is trying to make plasma. It's trying to make re-entry heat inside of the reactor, and that re-entry heat can heat up things, and you can use that to generate electrical power. You could use it to heat up water if you wanted to, right? But the heat is so ridiculously high that it melts most metals. So we need to keep it contained inside of a magnetic field, right? Just like the Earth has a magnetic field that prevents ionic radiation from frying us here on the surface. Same thing, only keeping the radiation in, not out. So that is another proven phenomenon. Us existing proves that you can use a magnetic field to contain basically radiation that's a byproduct of fusion. The Earth is a very good case study for that, and the Sun is a very good case study that fusion happens. There's nothing here that can't be done because it happens naturally, right? What a magnetic containment fusion rocket is comparatively to a reactor is the magnetic field, instead of being shaped like a toroid, so like a torus, it's shaped like a donut. They just make the magnetic field shaped like a rocket engine, and it shoots plasma out the back. Literally a rocket that generates re-entry heat for propulsion. That's cool, man. That's not impossible. I don't think that's impossible. It occurs naturally in the universe all the time. We can figure that one out. We just gotta figure that one out. Just gotta figure that one out. That's the tough part. Even better is just throwing mass anything into a micro black hole. This outputs crazy amounts of energy. Yeah, someday, Tessa. Gotta get near them to figure out how they work. Yeah, they're working at fusion at Johns Hopkins. Yeah, I mean, this stuff's cool, man. That's getting into, like, what physicists do and stuff. That's totally possible. We just got to figure out the right way to do it. Just like nuclear reactions were theorized in the 1800s. But we didn't, it took a second for us to figure that one out. That you can use, well, we figured out radioactive decay and why they generate heat. And then somebody else, Einstein, came and, well, it was Einstein and Heisenberg and Fermi, if I'm remembering right. They theorized that you could use radioactive decay to create what's called a chain reaction. If you have a nuclear material or radioactive material that reaches critical mass, basically heat it up fast enough and have it reach critical mass so it can't absorb much more heat, it basically divides by zero and just splits atoms left and right. Yeah, you basically nuclear weapons and nuclear reactions are just basically Kraken striking radioactive materials. It's the same thing. It's just a Kraken strike in real life. That's all. That's what a nuke is. Micro black holes are something you can have in a room as long as you stay several feet away. You're good. Well, that'd be cool. Now you're thinking with portals, Tessa. The first nuclear reactor ever produced enough electricity to power a light bulb. Yeah, of course. Would it make sense to do riskier fusion experiments on the moon in low Earth orbit? Yeah, Karate, I would. I'll be honest. I would. Yeah, I wouldn't screw around with something like that on Earth. But we don't really have a choice with that right now, do we? Wasn't there a debate whether they were unsure if the atom bomb would just cascade through the atmosphere and kill us all? Yeah, NX. Turns out that nuclear material is still subject to conservation of energy. Yeah. So, like, they thought that, yeah, it could theoretically create a cascading effect that could kill everyone. I mean, that would suck. But it turns out that how radioactive decay happens over time, think of it like a fuse. Like you light the fuse and then over time, after a certain amount of time, a half-life, it'll just decay. It'll become inert. It won't be radioactive anymore. A nuclear bomb is like hitting that fuse with a flamethrower and lighting it all on fire all at once. That's what a nuke does. It turns out that nukes are still subject to the laws of conservation of energy because of half-life. Because radioactive materials, per their half-life, depending on the isotope, right? They will decay. They'll eventually inert themselves, so to speak. ITER. Yeah, ITER is cool, man. I showed a video on Space News a couple months ago about all the ITER subassemblies and how it goes together. Man, that's wild. That's so damn cool. Hey, off from lunch. Did I miss KSP? No, we're nerding out. We're nerding out over stuff. Just to clarify, we've been doing fusion since the first particle accelerators. Yeah, no, humans can achieve fusion. It's sustainable. We can't keep it going. We can't keep it going. We haven't figured out how to keep it working like the sun. The sun just keeps going. We can't, like... Think of it like a car that has an empty tank of gas, right? There might be still some gas in the fuel lines on the car, so when you go to start it, right? That's where we're at with fusion. We haven't figured out a way to fill up the gas tank, so to speak. But man, if we nail... Hearts of Iron is $1 on Humble Bundle. Cool. If we nail fusion, guys... Oh. If we nail fusion, that whole carbon emissions thing, yeah, no, we don't need to worry about that. Yeah, we don't need to worry about that no more. Don't get me wrong. Figuring out fusion is just going to create another problem somewhere, and someone's going to get mad about that. Rightly so, probably, you know. But yeah, it'll solve a lot of problems that we have now. It'll probably make more problems down the road, because most of the time this does. Building a nuclear weapon solved the problems for the time, but did create some problems down the road, so to speak. I mean, if we want to really look at that way. Your engine sounds are spot on. Nice. Can and will run out. The sun will run out too. Eventually, Eukerman. Yeah, eventually the sun's going to fizzle out. Don't worry. It ain't happening anytime soon. Yeah, exactly, Buck. Takes more energy. How do we get it to sustain, man? Once we figure it out, Loki will show up. Or some aliens or something. Yep. I mean, we're close. We're close. It's going to take some time. ITER can hopefully help us answer some questions. Decided on only discussing KH7 and KH9. Nothing new after 1990. Good call. Creeper, don't get me wrong. Most of the information that you can find on this stuff on the internet is conforming to ITAR and operational security. Some of it is not. Some of it absolutely isn't. Dude, people link me pictures of leaked stuff from SpaceX that violates ITAR all the time. And because SpaceX is a defense launch vehicle, thereby violating ITAR as well, I make it a thing to not show that on stream. There's a very good reason for that. Yeah, we'll find the Vulcans, that's right. Isn't helium-3 fusion a big deal? And a reason to go mine the moon? I don't know totally Kickning if it is or it isn't. I have no idea. That sounds right, but I can't say for sure. G prefers not to get visited by the unfriendly men in suits. Yeah, I don't need to do that. I mean, Buck, think about how much of a cluster that would actually be. Seriously. They're gonna come to me, they're gonna come to Twitch. If I did something stupid like that, they'll come here, they'll definitely go to Twitch. And that would be very bad for the platform, I think. Yeah. Oh, there were some coffee grounds in there. Ugh, gross. Oh, why is there coffee grounds in there? Oh, that doesn't taste very good. Ugh. All right. Well, that's a good time to segue back over here. All right, let's keep going with the arrow shell. I'm going to work on the front of the arrow shell today. Well, I screwed that up. Focus. She said focus. Yeah, whatever. It's scaled proportionally, Swishio. I went through the scaling. This should be exact. I'm running into some tiny scaling problems here and here. But I have a, see there's a gap right there. When you scale up that gap, it gets that big. But this should be about right, more or less. All right, so I gotta rotate this one 5 degrees, right? And then we gotta use local and move it up. And then I gotta kind of go in here and manually tweak this so the seams are right. And then that's that one right there. And then the last one, last triangle point is another 5 degrees upward. I just got to make sure, see that seam right there? We got to make sure there's no seam. Is everything here correct? Not saying, just saying, you kind of admitted to participating in treason against the USA. Unless you really want to go to Guantanamo, I'd stop. You kind of, not saying, just saying, you kind of admitted to participating. Yeah, sure, Eagle. Okay. People send me this stuff and I purposely, it ends with me on purpose. And I mean, I don't know if, I know what you're trying to say. I get it. But the funny thing is, let's just say I've talked to people about this and what I'm doing is the correct thing to do. Picking up what I'm laying down? Okay, spoiler alert. I don't have the Space Force hat for no reason, okay? You remember the Space Force hat? No, trust me. Trust me on that one. I know what you're trying to say, and on any other occasion you'd be right. But no, I made sure to go through the proper channels with this stuff. Because it's ITAR. A lot of the stuff we talk about, bro, I trust me, man. I'm way smarter than that. Like, I'm not trying to toot my own horn, but I know what you're trying to say. Yeah, Lig, it's more like that. Now, these people that go and take pictures of stuff that they shouldn't take pictures of, and then post that on the internet, that's the problem. I can't help if stuff gets linked to me. But I make sure I don't show this stuff on stream. People link stuff to me all the time. I never show it. I never will. You gotta be so careful with that stuff. Heck, Eagle, the frickin'... Dude, the Air Force posted... Dude, the Air Force fricking... the Air Force posted stuff that violates ITAR. It's ridiculous. Like, who is clearing this stuff, man? Here, I have a picture. I'll show you. I edited the picture, and I edited the picture on purpose. Because dude, I don't care if the Air Force posted it. I know what's ITAR and what isn't. Where is it? It's in here somewhere. No. I know, just because people are gonna see. It's a artist that did anime versions of spaceships a little while ago. This person's on Twitter. I forget their name. Like, and I suppose if you wanted to go figure this picture out, you know what? Screw that. I'm not even gonna show it. It's not even worth it. It's in here somewhere, though. They showed pictures of the injector plate on a Merlin. I'm like, what are you doing? Yeah, the Air Force. They were like, yeah, super psyched about the next national security mission for Falcon 9. Literally shows the injector plate on the Merlin. Or it's not an injector plate, it's a pintle injector. And I'm sitting there going, oh my god, what are you doing? Dude, why did you post that? It's so stupid. It was in the top right of your collection as you closed it. Yeah, it's just looking up the business end of a Falcon 9. I'm like... Yo, if I posted that, if I took that picture and I posted it on the internet, people would show up at my house. And that's not even a judgment call. That absolutely would happen. Yeah, unbelievable. I have the picture up now. I'm not going to show it. PA violates OPSEC all the time. I'm like, dude, do you care that you could get somebody killed with this? Like... No, just gotta take pictures of the rocket, right? It's so cool. It's totally fine, guys. No one's gonna look at it. But anyway. It's just pictures that you shouldn't see, dudes. I'm not, you know what? I decided I'm not gonna show it. But anyway, let's get back to work. Yeah, Havocs. Because it's all cool, right? We have, you know, it's not like there's people that want to steal that technology and figure out where our fleets are. You know, situational awareness on the battlefield. Electronic or conventional battlefield or whatever. Yeah, that's no big deal, right? No, that doesn't matter in any type of warfare, right? See you! Hey Jay, thanks for the content. Fantastico. Ciao from Italy. Ciao. Come stai, amico? Grazie. Grazie. Thanks, CU. I appreciate it. Have you applied for a mission deadline extension yet? Jim, I'm going to get as far as I can until the deadline expires, and then we'll go. See where it goes from there. Yeah, Creeper, I know who's a vet that watches the stream, who's active, who's non-active, because you guys tell me, but... Like, Creeper, I'm not going to ask you what you were working on the other day. Only if you tell me, dude. I'm very, 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 very careful, and I take that very, very seriously. Sì, ragazzi! Grazie, ragazzi. Forza Ferrari! Scuderia Ferrari, numero uno del mondo. In the early 90s, I had a friend who was learning computer science and tried to brute force into one of NASA's servers. The FBI showed up at his house. Yep. Fine, man. Have a good stream. Alright, man. Be good. Alright, so... Yeah, Creeper, sometimes it happens, dude. Sometimes people slip up, and I usually am just like, oh yeah, that's cool. I try to try to draw away from that conversation, you know? Power stream, yep. Alright. So, I'm noticing some things. So, I copied the angles of the arrow shell. So, the arrow shell has like a center part of the hierarchy. Here, I'm just going to get rid of this for now. So, that triangle's connected to that triangle. That one's connected to that one. That one's connected to that one. That one's connected to that one, right? And then these triangles are node attached out. So, the hierarchy looks like a rib cage. So, it goes out like this. And these, I set the master triangles to the exact same angle that they are over here, and the nose cone isn't right. The nose cone on my forward bilobe tank isn't correct. The nose cone needs to go out to here, and it needs to clip. So, now I'm thinking something is peculiar with the front nose cone. Huh. Why would it do that? I'm confused. Patrick, I'm confused. Yes, I am. Yeah, that's right, Smirks. Working on the big boy. Some of these relationships on these parts aren't exactly right. Now, we know that the rear tanks are proportional, but I might need to go in and remeasure it again because I'm noticing... So this was the first sign that something was incorrect. There's a gap right there. There shouldn't be a gap that big right there. There is a gap on the regular SSTO now that I'm looking at it. Right? And I kind of buttoned it up a little bit to make it look like it's one piece by moving some of the triangles around. And even then, you still get some triangles that are clipping. But we're not seeing that going on over here with the scaled big one. So something peculiar is happening here with our scaling, and I'm not sure what it is. Yeah, I just realized how big it is. That's right. A Kerbal with a spacesuit, guys, once again, is once again about that big. That's how big a Kerbal is with the spacesuit on. I mean, look at the Kerbals down there, see? Thing's freaking massive. Even if I had all the schemes and all the injectors ever seen, I still couldn't do anything useful to get a rocket, not even to my neighbor's garden. But I understand we're talking about organizations and nations here, not individuals. Yeah, Swishio, but... You're right, but even seeing a picture of it... See, that's the thing. Governments have resources. Other governments have resources. They have engineers. All the engineers need to do is see a picture of it, and they should be able to figure it out. Just like we can reverse engineer Starship, right? And try to figure it out from there. Now, I get it. Does that mean I could build Starship? No. But I'm not a government either. Big Chungus and Lil Chungus. That's right. Clean face, man. Rip mustache. It'll come back, Taco. And in greater numbers. Are the things they take photos of are in public view? Yeah. We can take photos of whatever we see in public. Sure. Geometry is happening. Increasing two sides of a triangle times 2 does not mean the third is also just times 2. Yeah, to an extent. To an extent, Al, but yeah, they're... I don't know if I got length right here, man. Yeah, I mean, that could be the byproduct of geometry. Yeah, Al, more what I'm getting at is that I gotta figure out if it's just the geometry that's causing that problem, or did I scale something incorrectly? You know? That's more what I'm on about. Because this part is twice as big as that part. It should fit together. It's just a scale model, right? And once again, didn't make the nose cone correctly. Could you just slide inside the front section of the airframe back to close the gap? Kickning, I could. But then this thing, the whole point of building an exact model that's twice the scale of this thing with all the parts in relatively the same spot is because I already did all my aerodynamic research with this. Okay? I did all my aerodynamic. We know how this thing flies. If I make the same thing at twice the size, it should fly relatively similar. I should know what to expect, right? That's the idea here. Going around and changing things, changing it too much will make it fly differently. And that's a good way to not meet the deadline. 2020, a bit off topic. That's the name of this stream, dude. What's up? Remember the garden I had planted? I've already harvested some zucchini and my pumpkins are starting to fruit already. Plus my corn is sprouting well so far. Cool. That's awesome, man. Yeah, in the planters. And I was like, dude, go down and get some lumber. Yeah. I'll take comments that EJ made that didn't age well. Go get some lumber. It'll be fine. Go get some lumber, they said. It's cheap, they said. Bobby, we had a conversation about operational security. I'm not, yeah. Hey, Isley, what's up? Enjoyed the Tori Bruno interview. I did. I actually used some of the information from that interview, dude, when I was explaining things. Tori Bruno pretty much very astutely explained why ULA exists at the very beginning of the interview. Yeah. I actually fell asleep listening to it last night. It was great. Great interview. I didn't work my way through all of it, but the parts that I was hearing were great. When Tori Bruno was describing the octogrid and how the octogrid works and how it's different than an isogrid and how the isogrid is heavier despite being geometrically simpler. Dude, so good. So good, man. It should be about the same, T-Man. Yeah, should be. But I'm thinking that I have some proportion problems with my front tank. Alex, Tori Bruno's crazy. Like, in a good way, in a good way, in a good way. Not crazy in a bad way. Alex, like, he's what I like to call, he's old school American. That's how, like, not whatever we've become now. Like, I'm sure some people like that somewhere. Tori Bruno's old school. He doesn't boast. He doesn't brag. He does his talking with his work and lets his work ethic speak for itself. That's old school, man. That is old school American. That's what I like. I do that. You know? I let the stream's content speak for itself, which is funny because I talk on it all the time. But that's part of it, you know? Off to a job interview. All right, Ishiku. In other news, it's a cool 97 degrees in Vegas today. Oof. He flexes with his mustache. Now, be like Tori Bruno, man. Old school. That's old school, dude. I like that. I like that old school mentality where you do your talking on the field, man. It's something that I learned playing American Hand Egg. Do your talking on the damn field. Anybody can talk crap. Talk is cheap. Actions are better. I like that. That's Tori Bruno in a nutshell, at least in my mind. Okay. See, now I gotta see something here. So, I gotta see how much these tanks are clipping into each other, and then I gotta see how much these tanks are clipping into each other. Oh. Not the same. Not the same at all. The outer tank wall from the port side bilobe tank is touching that right there. Ooh. I should measure center point to center point on these tanks. Because I know the back tanks are scaled correctly. I built them directly off of these tanks, but I never checked the front bilobe tank. Which is why I'm running, that's why I'm running into some scale problems up here. but not necessarily back here. TB is great. I wish ULA wasn't beholden to stockholders and can innovate more wildly. Havoc's, they are, man. They are. Like, it's just, they're not innovating in the same way that SpaceX is doing it. Dude, I'm telling you. Okay, like, you needn't look no further than, okay, rocket comparison. Right? You didn't look no further than a rocket comparison chart. Let me find one with Vulcan on it. Dude, Vulcan is a monster for what it does. It is ridiculous what that rocket can do for its size. There's Ariane 4, Long March 3, Zenit, Saturn 1B. This is not to scale. That's not to scale at all. There's Atlas 3, Titan, Proton, Titan 4, Atlas. I gotta find a comparison with Vulcan. The reason why, you know, I want to show you guys a comparison with Vulcan is because of its payload capacity relative to its size is unbelievable. Vulcan is a heavy launch vehicle, and it's as big as a medium launch vehicle. ULA is innovating in ways that we don't, it's a little bit harder to see. I'm just trying to find one with Vulcan in it. There it is. Sure. This will work. Alright, so look at Vulcan comparatively to like an Atlas, or an Ariane 5, or a Soyuz, or Antares, right? This thing, Vulcan can, on its upper end, in its 6 rocket configuration, is pushing Falcon Heavy. If I'm remembering that right. It might be a little less. Hold on. Wait, no, maybe not Falcon Heavy. Hang on, I gotta double check myself. That doesn't sound right. So heavy. Okay, no, not pushing Falcon Heavy. Pushing Falcon 9 expendable. There you go. Okay, cool. Alright, low Earth orbit ISS is 26. 26, so that's 60,000 pounds. I think I got pounds and kilograms confused for a second there. Sorry about that, I apologize. Hey, Evil, what's going on? That is ridiculous for its size. Even that right there, that's as much as Delta 4 Heavy. And it's a single stick configuration. Shuttle? It's a single stick configuration, which is bananas to me. I mean, some of these numbers are insane for what it is. With no solids and just working off 2 BE4s, it can move 9,000 kilos. No problem. That is a nutty amount of payload to orbit for what it is. That's ridiculous. Because once again, like, look at Vulcan comparatively to like an Atlas V. It's not that much bigger. It's smaller than a Delta 4 Heavy, but moves more to space than Delta 4 Heavy. And ULA is also working on 2 major things. They are working on reusability. That's their ace in the hole, but they're quiet about it. They're cautious. They're cautiously approaching reusability, but they're approaching reusability in a different way that SpaceX is. ULA is working on making their upper stage reusable, not the first stage. With the first stage, they're focusing on a reuse called SMART, where they jettison the engines off the back. The aft thrust structure of the vehicle is actually popped off, and it parachutes down, and they catch it, and they bring the engines back. Now, the early versions of Vulcan will not have that, but Vulcan is built to be able to do that from the start. It's future-proofed, which is smart. And I'm telling you, their ace in the hole is Vulcan's upper stage. Vulcan's upper stage is insane. Insane. That's an old picture of Vulcan. This thing right here. That upper stage is ridiculous. So it's got twin RLCXs, right? In a 5-meter Centaur. They've never made a full 5-meter Centaur like this before. 5-meter balloon tank Centaur, and What they're trying to do is they're building in the future proofing into the 5-meter Centaur to make a reusable tug. So they're kind of combining an upper stage and a satellite into one thing, which is crazy. So like the upper stage can just sit there on orbit and station keep on orbit, and it could just sit there. And then you could launch another Vulcan with another upper stage that moves like something like this up into space, right? And then this thing will separate and it'll dock with the tug Vulcan, right? After it's been refueled or something. And then you could build architecture out to the moon. No problem. Vulcan is really good. It's really good because like I said, ULA is working on making upper stages fully reusable, not first stages. Differences. They didn't abandon it, Apatoxin. They changed all the things around. They changed it around, and they switched to building a baseline version of Vulcan that has all the bells and whistles to be used this way. So like, you know, everybody says, oh, ULA, their new rocket isn't reusable. Well, in the future, there could be a version of Vulcan that dumps the engines off the back, and they bring the engines back and attach it to a new Vulcan core, right? And then they build a space station that's designed to hold these tugs in place, and we have a gas station in low Earth orbit. That's what you could do with ULA. And their upper stages are using hydrolocks. Hydrolocks, hydrogen and liquid oxygen, the moon has ice on it. So it'd be, don't get me wrong, SpaceX, if they brought the carbon with them, could do the same thing on the moon. They could make propellant up there. But with ULA, it's much, the stage is built in anticipation for a cislunar economy, which is really freaking smart, man. And then ULA could, like, for instance, work with Blue Origin, right? ULA could put a fully fueled tug up there. They could launch a version of Vulcan with no fairing on the top and just a nose cone. Get this thing not fully fueled into orbit, but they could get one of these things into orbit or carry a big fuel tank in the front that feeds into the stage, right? And then Blue Origin could bring a payload up with New Glenn, attach it to this, and since this thing is reusable, they could send it out to the moon. Like, and, you know, before you say, why would ULA work with Blue Origin? Well, their engines are Blue Origin engines. That's what, ULA is quietly pursuing this stuff. Don't get me wrong, I wish they would talk about it more. That would be really nice. But they're quietly pursuing that stuff. Yeah. They don't talk about it that much, which is annoying because I really wish they did. They only talk about it if people ask. Centaur 3 can do 7 to 8 hours before one of the consumables runs out. Centaur 5 Mark 1 can do 12 hours out of the box. Mark 2, 5 to 6 months. I don't think people realize how useful a 5-meter hydrolox upper stage can be for building tugs. Transfer stages for the moon. Building stuff to get between Gateway and low lunar orbit. Oh, they're built. ULA built that stage anticipating that. A cislunar economy. Anticipating the logistic structure that you'd need to get stuff from Gateway down to low lunar orbit and eventually maybe even down to the surface. It's a space tug. Freaking space tug. I mean, that's a big deal, guys. That's, in my mind, that's just as cool as Starship. But it's cool in a different way. Do I think Starship does everything that ULA Centaur can do, and then some, and it can land, it can come back down, right? Which is more capability, right? But you gotta, once again, you gotta go back to, you gotta understand that ULA is cautiously pursuing reusability. They're not all in on it like SpaceX is. They basically want SpaceX to prove that it's viable, and then they'll start looking more into it. Centaur Mark II sounds like a good place to start a propellant depot. That's what ULA is thinking about. Trust me, man. Tori Bruno wouldn't steer you wrong on this one, dude. And he's been very consistent in how he's explained it. Like I said, TB's old school. He'll tell you what he can, and the stuff that he tells you is most likely going to be a thing, right? But he won't... I don't think... He wouldn't lie. Tori Bruno doesn't strike me as a liar type. I don't think he is at all. I get the exact opposite vibe from him, to be honest with you. Hang on, guys. So I got to make sure that these tanks are configured in the exact same way that those tanks are configured, and then I got to make sure that the fairing is configured correctly as well. That's going to be a little bit of a troublesome thing to do, because that fairing is the root part here, so we might have to do some rocket surgery here. I'm just trying to understand how monetarily they can afford to keep throwing away the boosters. Sai, that I can explain it. I know how to explain it, and it makes sense, but I kind of have to get to work on this, dude. We've been kind of doing some space news stuff here. But I'll try to talk and work, I suppose. Long story short, an expendable architecture makes sense when you have an infrequency of launch. What does that mean in plain English? If you don't launch a lot, making a reusable vehicle doesn't make any sense. If I was a millionaire and I owned a 747, fully reusable, obviously it's a 747, right? If I was a millionaire or a billionaire and I owned a 747 and I flew it maybe once a year, it doesn't make sense monetarily, right? You'd charter the airplane, right? Why would I do that? Why would I pay for all the maintenance fees, all the storage fees, everything to have a 747 if I'm going to use it once a year, right? That's why airliners want their planes to fly. They offer new routes. They do all kinds of stuff to try and, well, get people to freaking fly. Rockets kind of work in that same regard right now because, well, it's expensive to make it reusable, but it was expensive to make airplanes reusable at one time too. Like the Wright Flyer had to use a catapult to take off, but that's another story. So hang on one second. Get rid of that. So hang on. Let me just regain my train of thought there for a second. My brain divided by 0. So if you're not launching a lot, it doesn't make sense to make it reusable. The amount of money that you would invest in, keep in mind they can't just buy a 747. They would have to make it themselves. They don't want to incur the development costs. They can't. It's not financially viable because they don't launch very much. But with ULA, how Tory Bruno positioned that company, they positioned it for defense contracts. But the thing about defense contracts is, once again, I was talking about this at the beginning of the stream, it's sinusoidal. So one year you might have 6 launches. The next year you might have 12. The next year you might have none. ULA is set up in anticipation of that market, not what SpaceX is set up for. SpaceX is set up for building an internet satellite constellation, for instance. That's the whole reason why Falcon 9 Block 5 was developed, because you're flying basically once a week with Starlink. Not right now, but you get the idea. They're flying once a week with Starlink, and you need a rocket, you need a lot of rockets. At that point, it makes sense to make it reusable. ULA doesn't have that right now. Like my gym membership. Oof. Oof. But yeah. So, let's go over here. See what I'm talking about? That's why they don't just do reusability, because it's not part of their business model. And the crazy part is that it's not part of their business model, and they're still doing it, which is pretty damn cool. That's what I mean about Tory Bruno, dude. There's a reason why I have him in mission control, and it's not because he's just the CEO of another freaking company, right? I have Tory Bruno in there because what he's done with ULA is position them into a place where it doesn't financially make sense for them to do reusability, and still is pursuing reusability. He's turned around, he's turned a contractor around from a basically a government-dependent contractor, right? And even though he positioned himself for defense contracts, Tory Bruno made a partnership with Jeff Bezos. And Atlas V is going to launch 9 times, launching Amazon's satellite constellation in space 9 times, and you can be damn sure they're going to do it like 9 times in a year. He's not only positioned himself to be relatively competitive in the commercial market, but very competitive in the defense contracting department. He took a company that was wholly dependent on defense contracts and pivoted it away from that, and also pursued reusability at the same time. Guy's a freaking genius. Like, a freaking genius. Hey, Enraged, how goes the SSTO? I don't think I got my forward tank proportions right, dude, so I'm doing some measuring from the old SSTO tank to the new one. And once again, yeah, I don't think we're correct here. And I think it's because my adapters are different lengths. Yeah, Tori Bruno also worked on the X-33, on a side note. Guy, I'm telling you, man, guy's a friggin' genius. Like, galaxy brain. Really smart. You'd be hard-pressed to find somebody smarter than that. What are you trying to figure out? Well, Hellfish, proportions, long story short. Do these look proportional to you? They don't to me. And that's because this adapter, the angle of the conic adapter here and the angle of that conic adapter are not the same length. And I think that's where I'm getting messed up. The length of that conic adapter and that conic adapter is not the same either, which is problematic. That would mean I need to space these tanks out to be in the same set positions as this. Uh-oh. Oh, dear. Okay, guys, I gotta do some measuring. Alright, kill the conversations, the Q&A stuff. Conversations about ULA for a moment, please. I have to figure this out. So I need to find the center points of all the tanks, and then we need to measure the distance between center point of that tank, and that tank. And then I need to figure out a way to redo the fairing shape. And then the hard part is I need to go back into the prototype, and because that's the root part of the prototype... Oh gosh, I might have to graft it on. Oh, that would suck. Alright, well I gotta do some measurement. Why is Peter Beck in your Mission Control Center? Swishio, if I told you 10 years ago that there would be a guy that made a carbon composite rocket and flies it out of New Zealand, would you look at me funny? Peter Beck just pretty much made a small sat launcher out of nothing, which is pretty impressive in itself, dude. Like, Rocket Lab just kind of came out of nowhere, dude. That's why they're cool, man. Like, you know, 10 years ago, if you said, oh yeah, carbon composite small sat launcher with electric actuated engines, people would be like, nah, that's not really how that works. Just like, you know, people would say, oh, you can't 10 years ago, people would say, hey, you can't propulsively land a rocket, that's impossible. Okay. Yeah, frickin' Rutherford engines, man. So I'm trying to use these cubic octags to find the center point of each one of the tanks, and then I'm going to proportionally try and move these tanks into the same positions. I noticed some scaling problems when I tried to make the arrow shell for the big SSTO, guys. So he also ate a hat. Coldest place in the universe. Yeah, right. Alright, so there's my relationship between the tanks, okay? Now what I need to do is... Okay. I need to go down here. Well, I need to measure here. Hold on. So, So the distance between, if this is absolute snapped at the point where the girder segment meets the fairing, right? So we're going to take some measurements here, right? And I'm going to use rulers to measure. There's a way that you can make rulers in KSP. It's not like a UI function. You can use them with struts. Headed out for a couple hours. Be back soon. All right, man. Alright, so now what I'm going to do is we have I-beam point, and as long as I put the I-beam right here in the same spot, the measurement should go. So now we need here to here, right? Put a cubic octag on top, right? And then take a strut and put a strut there, all right? The strut is the ruler for the most part. All right, so then we're gonna take this and we're just gonna move it up there like that, okay? Now copy that same piece, and put it right here, right? And now I'm gonna take that and I'm gonna angle it right there and there. Now we have that length, right? So I'm going to take that and move it up. Now we're going to take this, we're going to attach that right there, and I'm going to move this into position as well. It's just, this one wasn't an absolute snap, it's kind of a little bit off, but that's fine. Alright. Now, these guys right here are measuring the center line of the tank. And I'm going to actually put the rulers here, like that. And I want to make the rulers all one thing, and I'll tell you why in a moment. Okay, so what I'm doing is I'm measuring the center points between these tanks, because with the big SSTO, the tanks are a different shape. So what I'm going to have to do is make sure that these tanks are in the same positions despite being different shapes. Proportionally, it carries the right amount of fuel, but once again, the angle that this tank is at is not proportional to the angle that this one is at. So it's time for drawing with EJ. So if the original one is like this, right? Like, we have an angle like that, right? What I'm going to have to do, because these are not proportional shapes, right? The tank, the cylindric tank is proportional, but this one does something like that, right? If I have a center point here, a center point here, and a center point here of all three of the tanks, what I'm going to do is space these tanks out. Here, here, and here. And it's going to end up looking kind of like this. They're going to have spaces in between them, but proportionally they'll be in the same spots. You don't have to worry. You're not going to see it. It's going to be covered by the aero shell. But this should give me the correct fuel balancing that I have with the other one. Just delivered pizza to someone on a floaty in their pool. Nice, man. That's cool. So, we should be able to get the relative proportions here if I double the distance of every one of these things. And we can do that by basically copying this, right? Doing that, well, it has to be attached to the fairing. And then moving these into the exact same spot that they would be in, right? So, these are tanks that are twice the size. So if I duplicate this length right here, Okay, that is in the center of that I-beam. So if I duplicate the length... Alright, this should give me the center point of where these tanks need to be. Now, where is the center point? Where's the center line of these tanks? Yep, not proportional at all. Not proportional in the least. They are not even close. So that means these tanks need to be out here, like that, for it to be proportional. Oh. How much delta V to go from 100 by 100 to 20,000 by 20,000? 100 by 100 kilometers to 20,000 by 20,000 kilometers? I would factor in... That's 1,000 meters a second at least. Yeah, 1,000 should do it. It should be like 600-700 for the transfer burn, and then probably 200 to 300 for the circ burn at that altitude. Yeah, you might want a little bit more than 1,000. Someone's estimate is fine. 1,500 will do you right. 1,500 is guaranteed. I don't know what the exact number is. I know it's more than 1,000. I know it's less than 1,500. Yeah, it's like 1,250 or something like that. If I'm doing the math out off the top of my head correctly. Figure 1,500. Do it. Do it, Anakin. Do it. Alright, so now what we're going to do, I'm going to take these, I'm going to move them up, right? Now we should be able to get the center points for every tank here by taking this. So we're going to undo that for a second, just leave that there. Taking this, literally doubling the distance, because this is twice the size. And I know that that doesn't exactly work correctly, but it's close. It's good enough. Now, I'm going to take this, and I'm going to make sure I snap that to the center point. Our fairing isn't big enough. Wow, what's that, Reagan? Well then. Doors that open up like this! Not like this, or like this. These are not the doors of a billionaire, Richard. Dude, I told you. Shuttle-style cargo bay, man. The chomper isn't gonna work. It's not. That would suck for payload integration. Take it from somebody that knows a little bit about it. That's the way to do that. Perfect. Yeah, chompers are not gonna work, Havocs. It's gonna be it would be a nightmare to put payload in this thing. The shuttle doors that open up like this, as opposed to the chomper. So with the chomper, you'd have to go all the way back. You'd have to fold it 180 degrees and then load payload in. With this, you just open the doors, right in. No, this is real. That's a real picture. It's from Mary, or well, Chris Bergen. Mary took the picture. There you go. Shuttle payload bay doors, bro. Yeah, I told you. I told you, bro. No, that was a guess, and I was. As a shuttle fan, I was kind of hoping it ended up that way. I got lucky with getting this one right, I'll be honest. There's more stuff that I've predicted about Starship that I've gotten wrong than I've gotten right, but that one I did get right. So how do you utilize the space of the nose? Crew tank, man. Calling it now. That's my guess. I don't know the answer to that question, MotoKid. My guess is that there's going to be a crew tank up there. Starship has the same problem that every other re-entry vehicle has. You got to balance the fact that you have all those Raptor engines down at the bottom. Now, in the center of the vehicle, you don't necessarily need to worry about it. There's an empty fuel tank there, well, empty fuel tanks there and a payload bay. But the reason why they put the header tank up there in the first place, right, Reason why that's up there in the first place is to help balance the design. My guess is that this is where the HAB module is going to go. And there's, if you want me to go one better, I think there's going to be a shuttle style cabin up here. If you really want my honest opinion. Trust me, this is the shuttle. You could, you know, a lot of people criticize the shuttle's design, and once again, it ain't without criticism. I think it's a good design, but the way that Rockwell set it up with payload bay configuration and crew tank with engines at the back, friggin' genius, dude. And that was they came up with that in the 70s. 1972 is when they had the baseline configuration for the shuttle figured out. So like boosters, external tank, orbiter, they had that figured out in the 70s. The guy's drawing it on a friggin' blueprint. Like guys actually on a drafting table were drawing it out. They figured that out 50 years ago, man. And it's, dude, there's not really that much of a better way to do it if you want to make a reusable payload bay. Having the payload come out of the vehicle, like if the vehicle's facing this way, having the payload come out of the vehicle that way is the right move. Like, once again, that's the best. There's not that much of a better way to do that. The chomper fairing was a good idea. But the problem with the chomper fairing is that when you go to integrate something, if Starship's on the ground, how are you going to get the door out of the way? You'd have to lift something up with a crane, because the thing only opens like this much, right? You'd have to lift something up with a crane, lift it down, and then somehow get it to go diagonal with the crane. Cranes rely on keeping payloads plumb with gravity, so going diagonal with a crane means you're going to need a counterweight. You're going to need a counterweight to counterweigh the payload when you shift it laterally on some type of jig or whatever, right? Like the carts that they use to install the shuttle engines on the back of the orbiter. You need something like this that slides back and forth. See that? Yes, that guy is sitting on top of the shuttle engine installer. He's the guy that's controlling it. But the shuttle engines are tilted. Shuttle engines had that same exact problem. You don't want to hit the body flap, and you can't put them in like this because the mount for it is angled like that. So you had to pick them up, hold them like this, and install them like diagonally because they're diagonally mounted. A payload on Starship has that same problem, and that's where I recognized it. They have to, if you have doors that open up sideways like this, all you got to do is just slide the payload in on a cart and have a payload adapter at the bottom. This is the better way to do it. I'm telling you. Hell yeah, New Balance. Massachusetts company right there. Just take the door off. Hulk, see, I've had this conversation with people, and you're right. I've had this conversation with people many times in chat. You're correct. Taking the door off would fix that problem. But you, once again, think about it like an airplane. How much would it suck if every time you wanted to load baggage into a 747 or an A380 or something, you had to take the cargo doors off, install the cargo, and then put the doors back on and then close them? You're adding integration steps. That's the opposite of what SpaceX wants to do with Starship. Alright, so this tank needs to go 1, 2, 3 clicks back, and now it's proportionally in the right spot. Okay, so the next thing I need is right here, and then I need 2 of these, double up the distance, and then we need 2 of these to double up the distance to find out the center point for my forward tank. Ooh, okay. Is it going to be the return of a rotating service structure? Well, Apatoxin, no. Starship, my guess is that wherever Starship lands, it's going to have... Knowing SpaceX, to load payloads, you're probably going to have a more heavy-duty version of this. Or just a gantry crane. Gantry crane could do it. I wouldn't use a gantry crane. A gantry crane would only make sense if you could somehow take Starship and turn it horizontally. But Starship really shouldn't do that with Starship. But my guess is that SpaceX could do something like this, or if we're gonna go crazy here, Slick 6 out at Vandenberg has a good example of what it might look like. Slick 6 was a shuttle pad, but it was a shuttle pad that had no rotating service structure. But they still needed to install payloads in the shuttle, right? So, see the PCR? Payload changeout room? It's a big clean room, right? For installing payloads. So, they have payload processing over here, right? And then there's a crane in here. They pick the payload up. And then there's a bridge crane in here. The PCR would move backwards. The bridge crane would load the satellite into the payload changeout room. And the payload changeout room would roll all the way down here to the shuttle. And from there, they would just install the satellite on a cart. Like what they did in the rotating service structure. But it's not a rotating service structure. It's an axial service structure, I guess. If you wanted to call it anything. Probably a rolling VIF. Like a mobile service tower, someone. And I'll bet you they'll... And see... I'll bet you it's a mobile service tower. Someone. And I'll bet you it's a mobile service tower that's going to probably... If I had to guess... This is EJ's straight guessing time. I'll bet you that the payload changeout room for Starship ends up looking like the 39A Falcon Heavy service structure. Because why would SpaceX change the design? They're already being paid to develop that. Just build another one. Build another one and change out the decks on the mobile service structure for Starship instead. Actually, that makes a lot of sense. Huh. Yeah, but smaller? No, it wouldn't have to be. It wouldn't have to be much smaller or much bigger. A Starship is about the size of a Falcon 9 first stage. And if you know how those MSTs work, how the mobile service towers work, like the one that ULA has, there's a bridge crane at the top, right? And the bridge crane picks, you put the payload in from the back. And the bridge crane picks it up, it loads it into the changeout room, and the vehicle, the service tower moves there, and then like the mobile service tower that Delta Heavy has, they just place it down on top of the rocket. Trying to find a picture of it. There's a picture inside of the rotating service structure. See? It'll look exactly like this. You can make a little clean room right there, and then you literally just slide the payloads in. Due to the increase in mass and the corresponding increase to thermal velocity, will Starship be able to land if it needs to abort before deploying payload? I'm thinking, Madeep. That's a good question. Now, okay, man, I'm not SpaceX, so frick if I know. But I have messed around with building, like, Starship prototypes in KSP. And when I say I've messed around with building Starship prototypes, I mean I look at all the pictures and I study Starship to the point where we made a very, very high fidelity replica of it, something that looks and functions exactly like the real one. Well, I made it do this, okay? I made a Starship do that, no problem. And it's a 2-scale replica, so... I mean, I don't know. I don't have the most amount of experience with this, but I do have a good amount with it. I'll be honest with you, I don't see why they wouldn't be able to land with down mass. Starship theoretically, should be able to take up a very, very significant chunk of mass up and down. I mean, it's 100 tons on the way up. I would guess it's at least 40, 50 tons on the way down. I mean, your constriction there isn't the physics. At that point, Madeep, your constriction is how much fuel you have left over. And I suppose if Starship aborts, it'll have plenty of fuel left over. Now, at that point, now the real question to ask is, so say Starship is carrying 100 tons and it has to abort. So Starship would presumably do a boost back like Falcon 9 for an RTLS. It would come back down and turn. what you'd have to make sure your TWR is above 1. If your thrust to weight ratio is above 1, you ain't landing. I don't think mass balance is a problem, someone. That's what the wings are for. Mass balance is not an issue. In fact, putting more mass in the nose is going to make it more stable. It'll make it do that easier, not harder, right? It'll fly better with more mass in the nose. Yeah, Reagan, I have a long time ago. Have they updated it? Hey, Hammernails, what's going on? Can I see it? Alright, I just need to leave this craft file open. Let me see if I have a picture of it for you guys. I'm pretty sure I do. I'm pretty sure I took a picture of it. Let me go take a look. Yeah, there's Freedom. There's the custom launch. See, the reason why I know so much about mobile service towers, guys, if you don't know me, is because I build them in KSP. I don't just study the rockets. I study the end-to-end architecture. I build pads, and I build mobile service towers that assemble rockets on the pads. See? Like, there's me installing an upper stage on a first stage that was reused. There's Dart. See the first stages in the background over there? And see, there's me installing a shuttle. Where's the Starship model? And like I said, I know it's Kerbal. It's not... Oh, you can build an MSD in Kerbal. Does that mean you can build one in real life? No, probably not. But this gets the point across. The gist of it is there. Where is that? Oh, there it is. What do you think? See? Oh yeah, Berth. I don't mess around with KSP. I really... dude, I'd take my time and make it work. Can't remember the shuttle heaviest landing. The shuttle's down mass capability is 12,500 kilograms. I know that off the top of my head because I'm a loser and read about this way too much. Seriously, that's all I do. I do not have a social life outside of the stream. Except Remo, and that's it. Except my girlfriend. Last, please. Also, just jettison the payload. You're not going to have to, Swishio. Why not have the payload change-out room directly on the launch tower and have a bridge from the tower onto Starship? That could work too, Swish. Yeah, you could mount the payload change-out room right on the tower and have the payload change-out room just move up or down to get out of the way. That could work. I'm glad we have someone like you who takes the power of KSP to show you can really do with it. Thanks, man. Yeah, see? Actually, like I said, putting more stuff... I had this problem where I couldn't get these things to land correctly. And you needed to increase the size of the header tanks. That's how I know that if you put more stuff in the nose of Starship, it's going to fly better. Just like with the space shuttle. It'll re-enter a lot better. I don't know if it's around, Berth. I thought you looked different. Yeah, I was over it, dude. Just got sick of the mustache, man. I'm shopping for an office gaming chair. Which one do you have? IKEA Marcus. An IKEA Marcus chair. And it's literally one of the best chairs that you can buy for the price. Seriously. Hammernails, I'm not sponsored by IKEA or anything. I don't trust the Swedes. I think they're weird. Hey, Swedish people, don't look at me like that. You know exactly what I'm talking about, you freaking weirdos. I'm kidding. It's a joke. I'm not endorsed by them. I don't do any of that. I've had this chair since 2018, and I literally sit on it for 8 hours a day. I sit on it for 8 hours a day. I race with this chair. I'm constantly bashing the chair back and forth. I move around. I get up off of it. It's still in one piece. Like, you see how much... You can literally see how much this chair gets used, and it's still good. The only thing I've had to do with a Marcus chair is I need to take the Allen key and tighten up the armrests every once in a while. That's just because my freaking big meat hooks are hanging on the freaking armrest, and it kind of moves it out of the way from time to time. Swedish people, you alright? You keep hating on us because the reason why I do it is the same reason why I hate on Canadians. Because why would you? It's a joke. It's a joke. And why would you hate on Canadians? What did Canadians do? They're just. What do Canadians do? They're just up there. Swedish people are the Canadians of Europe. It's the same thing. You're just up there doing Swedish things. Why would you want healthcare? Too real, Pilch. Too real, bro. too real. No, too real. I'm getting us back to this. Too real, man. Abandoned thread. Pull the ripcord. Pull the ripcord. Run. Women and wogs first. Alright, so I'm going to move this cubic octag. I'm basically using it as a locator to find where the center point of this tank is. And now, okay, that's on the center point, because if I click on the tank and then I click on this, the manipulator is in the same spot. Perfect. Alright, so now let's move this up. Yeah, see, our tanks are way out of proportion. Uh-oh. This tank needs to be right here for it to be in the proportionate spot. This is important, guys, for the same reason that Starship... It's important for the same reason that Starship is going to have the payload base set up like this, dudes. The reason is because mass balance on anything that's coming back is huge. That's very, 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 very important. I need the mass, especially the mass up in the nose, to be distributed the same way between the small SSTO's forward tank and the large SSTO's forward tanks. If they're not the same, it's not going to fly the same. It'll fly worse. Swishio, I have to redo the fairing. They are definitely not occluded anymore, man. Some of them aren't in the right spots. But Swish, that tells me that my fairing shape isn't correct either. And I'm going to measure the fairing after this. Yeah, it's not there's no way. It might pick up that one, but this one is definitely not. What is the cost of 1 unit of fuel in this current save? I don't know. Not much. 135 costs 31,869 to 32,805. So 135 units of liquid fuel costs like $200. Fuel is not expensive in KSP. Monopropellant is the most expensive per unit. All right, now this one right here. They're rulers, Wookie. I went to go build the front arrow shell for the SSTO today, and I realized that my tanks are not in the right spots. The tank that I made for the front SSTO, for the front of the big SSTO, is not correct. So what I did was, these cubic octags are locators, and I'm measuring distances here. So this is from distance from the back of the fairing to the center of this tank, distance from the center of this tank to that tank, center of this tank to that tank, to get the relative positions. And now I have the big SSTO's tank down here, and I'm trying to get that right as well. And I'm noticing real quick that we are not even close to being proportionally correct. Like, we're not even close. And I know we're not close because, yeah, these octags aren't lining up, and that is also conclusive with what the arrow shell was doing when I went to build the big SSTO this morning. Proportionally, that's where the tanks need to be. Oh boy. And now, like I said, I know that's where the tanks need to be. I know the fairing is an incorrect shape. The fairing's got to be much bigger up at the front. So what I'm going to do is I'm going to move my measuring sticks out of the way. And then I'm going to move the smaller SSTO's tank out of the way as well. Yeah, guys, these cubic octags right here with the struts, they're rulers. I'm just using them to measure distances, that's all. So what I did was, up here, I measured the distance between these tanks, And because more or less the small SSTO is about half the size of the big, half the scale, not size, half the scale of the big SSTO, I doubled the distances between different points. So the distance between the center line and the center line of the tank, center line of the fairing and tank is that much. Down here, it's twice as much. And now proportionally, I took the distances and I multiplied the distances by 2 by putting 2 rulers on top of each other. So two of these on top of each other to get the right distances. And now we have the correct proportional. It is a proportional difference now. Now we just need to measure the fairing, which is going to be a little bit more difficult here. But once again, yeah, we got to make sure this is right. What I'm going to do, see, I'm not sure what I'm going to do, because now we're going to build this tank, right? And now I have to figure out a way to graft this onto the prototype. The problem is that the prototype is... the root part on the prototype is that piece. So... Houston, we got a problem. Check the heights of the 2 adapter tanks. I believe they won't be the same ratio. Yeah, the 375 to 25 adapter... or no, the 5 meter to 375 is not the same angle. It's not the same conic shape. And then this one is definitely not the same conic shape as that. These are shorter than those. Those adapters are just slightly longer, proportionally, Wookie. Yeah, that's what I noticed when I went and made the arrow shell. I'm like, that's not right. And now I know that the fairing isn't right either. So, what I'm going to do for the fairing is literally the same exact thing. I'm going to take an I-beam, and I'm going to measure the fairing shape now, and we're going to do the same thing. So, and I will use rulers to measure everything and make sure that it's right. And once again, I'm using the cubic octags as locators. They're locators to find, like, it's just a locator in a CAD system or Maya or Blender or whatever is just basically pointing out a 3D point in space. I was going through the user guide and I found this part interesting. Starship has the ability to mount supports along the sidewalls or nose to interface with trunnion-style interfaces on the payload, similar to those employed by NASA's space shuttle orbiters. Reagan, I didn't read that part. They must have updated it, dude. Have another shorter sections between every tank. Seems like it's a third bigger than you expected. Swishio, these tanks are proportional to each other. At least I'm pretty sure they are. They should be. If they're not, I'm going to be a little worried. 720 to 7040. Actually, Swish, let me check. I can't find any info on Starship's maximum landing weight. Maybe the DoD has an interest in it, hence it's not being published. Maudeeps, I'll be honest with you. That could be right, but I don't think SpaceX knows their down mass capability, dude. You know why? Vehicle isn't finished. That's like asking me what my SSTO will be able to take back down and up into space. I'm aiming for 18 tons, and theoretically I should be able to bring 18 tons of payload up and down, no problem. But I won't know until we won't know until we have a more finalized design. So we have 7,000. What's the correlation? 7,040 divided by 720 is 9.7. So 9.7 on that one. I'm wondering if these are equally as proportional. So 540 divided by 3520. Nope. Swish, we're not carrying proportional amounts of fuel. Uh-oh. Crap. This does not proportionally have the same amount of fuel as that. So this has 9.7 times the fuel. This has 6.5 times the fuel. What about this adapter here? You said this several streams ago. You'll have to adjust for mass. Yeah, Ocelot, I'm gonna be 100% real with you. I understand, and I remember the conversation distinctly. I didn't understand what you were saying, but you are exactly right. That's correct. Yeah, we're going to have to... You're right. We're going to have to take that into account. And guys, the reason why I'm being anal about this and the reason why this needs to work is because if I make the big SSTO exactly proportional to the small SSTO, it should fly the exact same. I've already done all my testing. I should only need to fly this once, and it should work on the first try if I fly it the exact same way that I fly that one. Is the mass ratio the same? Yes. I know that's right. The mass fraction is the same. Swishio. Yeah, it is. All of the tanks have the exact same mass fraction except for these guys. The 3 to 2.5, any Mark III parts have actually a poor, a lower mass ratio. These have worse. Oh, crap. I might need to go back to the drawing board, dude. Oh, frick. I need to check something, guys. So, I have this tank.
Discovery, go and throttle up.
We have this tank, and we have this tank. 2 times over, like that make up the back tanks, right? I want to see if proportionally my aft tanks are correct, and I really, really, really hope this is right. Hey, Tape, 16-month resub. These need to have the direct... They have to be directly proportional. If they're not, the aft tanks, we might have an issue. Do you have the nuke unlocked? I don't. No, I don't, Eukerman. I could unlock it, though, soon. Breaking. Orion's launch abort tower has just been made into the capsule ahead of the Artemis 1 launch. Sweet. Wow, where did Burt Reynolds go? I don't know. So, this tank carries 14,080. And divide that by 1440. 9.7. Oh, thank you, God. Okay. Our back tanks are proportional. Oh, somebody up there still likes me. That would have really sucked. And we know, we just measured that those tanks are proportional to each other. Okay, so my back tanks are proportionally correct. Good. Now, whether they're 9.7, they carry 9.7 times more fuel. Pretty much 10 times the fuel. But see, another thing we got to kind of take into account is I'm not sure if 10 times the amount of fuel would... The other SSDO takes 2 tons into space, and I want the big SSDO to take 18 tons into space. Nine times the amount. Wow. Man, that was just coincidence. Yeah, if I wanted to take... Now, keep in mind, another thing to take into account is that just because you have 9 times the fuel doesn't necessarily mean you can carry 9 times the payload. It's important that we get the overall mass fraction of that SSTO the exact same as the small one, and we should be able to carry more delta. We should be able to have about the same amount of delta V with 18 tons of payload. Do we need 9 times the thrust as well? I think so, but don't quote me on that one. That's the thing that's bugging me. Why is NASA going with the Lunar Gateway rather than Dr. Zubrin's Mars Direct? What are your thoughts? Not gonna lie, I'm a Zubrin fanboy. I like Zubrin. He's cool. His ideas about spaceflight are genius, dude. I remember watching videos on the Discovery Channel about space with him in the 90s, and him talking about how it's bullcrap that we're not on the moons of Saturn by now. And that was like in the 90s. And I'm like, who's that guy? I like that guy. Yeah. Direct is a good idea, Madip. I don't mind the Gateway. The Gateway is alright. Long story short, the SLS in the Artemis program is a compromised version of the Constellation architecture. Well, not in my opinion. It is. It's a Constellized? Nice. It is a compromised version of Constellation, and because it's a compromised version of Constellation, the architecture doesn't exactly make the most sense. The thing about the SLS program comparatively to Constellation is that SLS is way more sustainable. It's a lot easier to justify building this stupid rocket if we have a space station out by the moon that the rocket needs to deliver people to. That's why they did that. With Constellation, you don't necessarily have that. I mean, eventually Constellation would have, but we decided to save $30 billion over 10 years instead. One times 1 times 1 equals 1. 2 times 2 times 2 equals 8. And 2.13 times 2.13 equals 9.7. And Hunts, that's part, you know what? We can sit here and we can say, oh, that's dumb. Politics is the reason why? That's so stupid. That's so dumb. That's so dumb. You can sit here and say that, but politics is the reason why there's an American flag on the moon. Politics is the reason why the ISS exists. So, you know, like, I never found that argument saying that SLS is, oh, it's just a jobs program. It's just pork for politicians. Yeah, no crap. What was the Apollo program? You see what I'm saying, Ma? Yeah, so was the Apollo program. What's the difference? Well, the difference is deadlines. Deadlines. We choose to go to the moon in this decade and do the other things. Deadlines are the key. Now, the deadlines in the 60s manifested themselves because, you know, we need to beat the Soviet Union. Right? We got to beat the Soviet Union. We got to beat the Soviet Union. They're politically motivated deadlines, every single one of them. But deadlines is the way that you enforce accountability in a big government program like that. You have to have deadlines. If you don't have deadlines, nothing gets done. And look what happened when the SLS program came along. There was no deadline to get the thing up and running. They said, we might fly it sometime in 2017. And they said that in 2012. We might fly it in 2017? What the hell does that mean? See what I'm talking about, dude? I don't mind Gateway. I don't mind SLS. I understand, you know, it's there as a toll booth, like what Zubrin says. He's not wrong. It's there as a toll booth. But what does a toll booth do in real life? Like on a highway. A toll booth on a highway helps pave to keep the infrastructure going. So having Gateway as a toll booth is a way to make SLS financially and politically viable. Because, well, we wanted to do it with Constellation, but no, we can't spend money on the space. Can't do that. Let's do other things with it. I just got my test score, and needless to say, I bombed it with a 94. I need to be perfect. Ugh, there goes my perfect grade. I appreciate the exceptionalism, Airborne, but also 94 isn't bad. That's still an A. You need to keep my grade an A. If I miss a few more points, my grade will drop below an A, and I can't have that. Once again, I appreciate the exceptionalism. You're damn right you should get an A. And if you get a B in college, you get a B or a C on a course, that just means you're not utilizing the college to the fullest extent. You're simple as that. Going like through a Zoidberg. China are taking interest in Mars, and now maybe that will make an impact. I hope so, Maudie. Yeah. And I don't like that that's the way that we decided that we want to go into space. I think that's really stupid and kind of a borderline counterintuitive. You know, oh, well, you know, we got to do it because the Chinese are doing it. If you want my honest opinion, I don't even think the Chinese probably have something to do with it. But, Madeep, consider this. This is something I was thinking about a week ago when we had a conversation on stream about public-private partnerships. I personally think that SLS and Starship should exist at the same time because I do not want a corporation having the only viable way to get to the surface of the moon. I don't think we need to say why that would end poorly. Simultaneously, I don't want a government being the only one that has access to the moon either, because the government could just pull the plug on the program, like what happened during Apollo. I want both of those things working against each other. And I can tend to say that nowadays, it's not even the fact that China's going to do it. No government will allow a corporation to have capability that they can't have. That's not how governments work. Full stop. Not how governments work. No, the government has to be able to match the capability, right? You can't have citizens doing something that the government can't do. I think SpaceX alone is enough political motivation to have a space race between public and private partnerships. China notwithstanding. China's probably helping in that regard. Helping meaning, you know, it's a threat to national security. But one thing I've noticed, dude, is that governments don't like it when citizens of said government can do something that they can't. Good, Airborne. Put your noodle to the test, man. You're saying it's a lot of work? Good. A lot of work? Look, man, it's something that I like saying to people on stream. If it was easy, everyone would do it. Just like launching into space. If it was easy, everyone would do it. Yeah, Madeep, I put a lot of thought into this, dude. I could write a college thesis paper about this stuff. Musk is totally going to claim the moon as SpaceX property. I don't think he will, Wookie. I think Elon acts in good faith because the reason why he's doing what he's doing is in good faith. To, you know, for the good of the species, right? And I understand that and I respect the hell out of it. You know, I'm not saying if SpaceX lands people on the moon, right, that they'll be like, oh, it's ours, and they'll go all corporate greed on everybody. But you know, the second that someone sees that SpaceX is doing it, they're going to want to do it too, right? And another corporation, another entity that doesn't have the good intentions that SpaceX has could really exploit that, you know, clause. And that's what I mean about governments not liking that that citizens have capability that they don't. They don't like it. And that's not some crazy, freaking stupid, like, right-wing way of looking at things. It's, you know, there needs to be some regulation somewhere or else we wouldn't be living in a society. Because remember, chat, we live in a society, okay? Alright? It's important to understand that we live in a society, okay? We live in a society? We, in fact, live in a society. Governments like even less when other governments can do what they can't do. Correct? Okay, but the moon is literally the first place humans have ever been able to colonize without some abhorrent human rights violation. Even if he claimed the moon as his personal property, he would still be the most benevolent imperialist to ever exist. Like I said, you know, when I talk about corporations having capability that the government does, SpaceX, I would say, is exempt from that, to be honest with you, because of the intentions. The intentions that SpaceX has are good intentions. But also, on the other hand, there's a saying, the road to hell is paved in good intentions. So, you know, a lot of people say, like, oh, we should cancel SLS. SpaceX has that capability, not fully understanding that, basically privatizing our space program like that is not going to end well. It will lead to stagnation. It absolutely will. And like once again, it ain't even a judgment call. It'll lead to stagnation. And simultaneously, just the government being able to do it will also lead to stagnation. The only way we move forward is public-private partnerships and public-private competition. Having SpaceX and NASA. Having a healthy national space program as a benchmark for, you know, private people, private contractors to say they can do it better. That's the right move. And once again, I'm not saying that Elon Musk is going to go, like, techno-fascist on anybody. I don't think he would. The intentions are pretty damn genuine, if you ask me. But just because SpaceX can, like other corporations, man, that's what I'm worried about. But he is the Techno King. Oh God, you're right. Oh gosh, you're right. There's the point of the fairing right there. So I'm measuring the proportions on the fairing using cubic octags here. And these are just all the different points on the fairing, for the most part. Von Braun predicted it, right? You're not wrong, dude. From the user's guide, at the baseline reusable design, Starship can deliver 100 metric tons to low Earth orbit. Does this mean Starship may have expendable variants for payloads above that weight? No, refueling. There's no point in making an expendable version of Starship if you make something that can refuel on orbit. And 100 tons is a lot, Reagan. 100 tons, that's a lot of payload, man. I mean, the shuttle can move 25 tons into space with a 15-foot payload bay diameter. And it built the ISS. Imagine what Starship could do. And a lot of the ISS modules are not nowhere near 25 tons, for the most part. Imagine what you could do with Starship and its 9-meter payload bay. Make much bigger modules. 100 tons a pop, dude? Reagan, I think SpaceX chose that number for a very good reason. Elon chose 100 tons to orbit because he knows good and well that you cannot fit 100 tons of anything in Starship's payload bay. Period. You could fill Starship's payload bay up with concrete and it wouldn't even be close to 100 tons. You could fill it up with lead. No way. Tungsten? Mm-mm. There's no way you'd even get close to 100 tons, man. That's on purpose. That they did, like I said, they did the same thing with the shuttle. They put the shuttle at 25 metric tons to low Earth orbit. They did that on purpose because they knew that would be able to move anything and everything into space. SpaceX is doing the same thing with Starship. Pigzig, you could have a tanker version of Starship, and Starship's payload bay could be filled up with liquid fuel and oxidizer. That's not even close to 100 tons. You'd be carrying probably, I don't know, maybe an extra 50 tons of fuel. Starship could put that into space and bring it back down. That's what I mean. Elon is intentionally over-engineering the rocket. SpaceX is over-engineering the rocket on purpose to be able to make it the end-all, be-all solution to moving anything into space at any time. And on top of that, they're making it very easy to manufacture them and very easy to fly them. They're trying to make it like an airplane. The airplane safety margins are insane for maximum payload. Theoretically, a 747 could carry twice as many people as it does. Sure, no problem. Of course it could. The 747 can literally carry a space shuttle on its back. A space shuttle is 60 tons of mass, 60,000 kilos, 132,000 pounds. And a 747 can carry it, no problem. Because the safety factors involved with engineering an airliner is like a safety factor of 1.5. That's what the 154 meme on this stream is all about. They're doing that with the rocket. They're anticipating, I'll bet you that SpaceX is anticipating 40, 50, 60-ton payloads at best. So they purposely introduced a safety margin in there and rounded it off right at 100 tons. Knowing full well they're never fitting 100 tons of anything in there. And basically that makes it so Starship can basically put whatever you want into space. A Tesla Roadster? You could put a Tesla Semi in there. You could put 4 Tesla Semis in there inside of Starship's payload bay. And you would be at maybe a quarter of the payload capacity. Starship could take those semi-trucks, bring them up, take them out, install them on the ISS, come back down, go back up again, grab them off of the ISS, put them back in the payload bay, and land. And you would never even get anywhere near its maximum payload capacity. Just like the shuttle, dude. I'm amazed at how many ideas Elon Musk is taking from the space shuttle. It's really smart. But he's taking all the good ideas from the space shuttle and getting rid of the perceived bad ideas and the perceived bottlenecks to reusability. Solid rocket boosters, towing them back, refurbishing them. That's a bottleneck because it takes a second to fish them out from the water, send them off to Utah, refurbish them, send them back, and stack them again. That's a bottleneck. They're trying to get rid of that by using liquid fuel rockets and producing the fuel on site. Dude, I'm telling you, man, if Starship continues unabated, it's going to be insane. In-freaking-sane. Just for nothing, you could fit over 12,000 metric tons into a starship. Yeah. What about Polyus? 80 tons. I don't think Polyus would physically fit inside Awuza, but I don't think it would physically fit inside of the payload bay. But if you like cut Polyus in half and put it side by side, then yeah, sure, of course. You could do that. It could take it up into space and bring it back down. Guys, Starship could bring down the entire ISS in pieces, no problem. Every single piece of the entire ISS, including the Russian module, it could bring it all down, no issue. Yeah, no problem. It wouldn't even, it's no sweat. You could bring down every piece of the ISS that the shuttle delivered and literally never go near Starship's maximum payload capacity. Ever. I still say it's for the crane that needs to be put on Mars. Yeah, goalie, I mean, you should double check your math. Starship's payload bay capacity means it can store a density of 0.1 gram per cubic centimeter, far less than the density of water, before hitting its mass limit. Starship's payload bay means it can store a density. What are you using for Starship's payload bay volume, Max? How many? Like, what's it? What? I'm using 1,000. Did I do my math wrong? Now I'm confused. I was using 1,000 cubic meters. Okay, hold on. Okay, you could fill it up with lead and it couldn't get it into space. Yep. Yeah, okay, maybe not lead. Maybe not lead. But any usable space payload. I mean, you could put lead in it. I mean, how much lead could you put in it before you reach 100 tons of lead? $1,000 or 1,100 is pretty close. 100 tons of water is 100 cubic meters. Yeah, okay. So I'm a little bit off, but dude, it's this damn metric, man. The damn metric is such a pain in the butt. You know what, man? I know that metric is easier to use. It still confuses me from time to time. Like, look, when I'm talking about feet and miles and pounds, there's no way you're ever going to get those misconstrued, ever, because they're feet, miles, and pounds, right? Sometimes I don't move the decimal point into the right spot. It's so stupid. Like, ugh. Goddamn metric system, man. What? Hey, look, I know it's easier, okay? I know it's easier. I'm sorry. Freaking, I learned Imperial first, man. That's so much easier in my brain because I learned that when I was a kid. I always mess up some mundane detail. See, the lead is 1135. If you move the decimal point over 2 places, then the math checks out, but that's not. And guys, I'm not saying that metric is stupid or it's way easier and you should use it for engineering, especially aerospace engineering. It's way easier. I'm just saying that I have to back convert the stupid thing. And sometimes I have to do the metric measurements and then convert it into feet and all this other stuff for me to understand. You could tell me something's 100 kilometers away and I would be like, all right. But you could say it's 62 miles away and I'd be like, oh yes, I know how long that is. Like, it's so dumb, dude. Press release. It happened. NASA awards launch services contract for the Europa Clipper mission. NASA has selected Space Exploration Technologies of Hawthorne, California to provide launch services for Earth's first mission to conduct detailed investigations of Jupiter's moon, Europa. The Europa Clipper mission will launch in October of 2024 on a Falcon Heavy rocket from Launch Complex 39A at Kennedy Space Center. The total contract award was approximately $178 million. I'm just gonna go back to using kilofeet. Don't worry about it. If you got everything perfect, you've robbed me of the joy of correcting you. Yeah, but I don't like. Yeah, but a miscalculation like that really throws a monkey wrench into my thesis about how Starship is supposed to work. I still think that it's designed to move whatever space payload you can, and like the lead. I would call it not even an analogy anymore. The lead. Saying you could move lead into space as a raw material is more hyperbole than anything. Probably should have checked my numbers on that one. But it's more to facilitate like the idea, dude. Like Starship is, dude. What is there a market for launching 100-ton payloads into space? No, not even close. So once again, how the heck did Berger know this contract happened before the release? Because he's in a politician's pocket, Phil. That's not hard to understand. That's true. There are very low density satellite buses. You can just teach people that, yes, some satellites are pretty light given their volume. They're not solid metal. Yeah, I mean, but see, then again, Max, like now that I'm thinking about it, it's a chicken and the egg argument. Making 100-ton, if you make a vehicle with 100-ton payload capacity to deliver stuff into orbit, when there's no market for 100-ton payload capacity, will people start making payloads that fit to Starship? Or will Starship just keep launching the same amount of payloads over and over again? It's chicken and the egg. Now, if you compare it to other forms of transportation, right? If you compare it to other forms of transportation, you know, like airplanes, for instance. Airplanes started by moving the mail. That technology for moving the U.S. mail over long distances transferred into moving bombs over long distances, and that paid off in World War II for us pretty well, I would say. And then that's what led to low-cost commercial fares, right? It eventually led to the jet age and revolutionized how we move around this planet with a bypass turbofan design. And that's, you know, like the 747 is the culmination of all of that, right? We were supposed to go further. We should have gone further with supersonic transports and, you know, stuff like that, but that never happened. You know, so did they, you know, like when they went to say like, hey, we need planes to move mail around, right? Did they anticipate that we would move cargo and trucks and cars and stuff and people around on planes as much as we do? No. But it's a, you know, with the planes, it kind of was the logical conclusion. You know, with cars, right, Henry Ford started making the Model T, and Benz started making the Daimler-Benz Motorwagen, right? Henry Ford started mass producing them. Did they anticipate that the car would turn into the truck? No. They just took a Model T and put a flatbed on the back and said, wow, this is really useful. And then, you know, then they said put a bigger cargo box in the back. And then now let's make the cargo box separate and make it articulated. Like the semi-truck, they didn't plan to build, like when they started making cars, they didn't plan to build the freaking, you know, a big rig. That's just kind of what came of it, you know? Now, like with Starship, you know, you can't predict the future. Who knows? Yeah. Elon is good at creating his own markets. True that. I don't doubt that we'll find a use for 100-ton payloads, and I think that bay capacity isn't a huge overshoot, nor an undershoot of for 100 tons. Max, I still think that there, you know, like the math disagrees, but I still think that that payload bay is designed based off of market analyzation of payloads going into space, including internal payloads at SpaceX. I think SpaceX, when they designed Starship and they designed that payload bay, they looked at every type of payload that gets launched into space and then multiplied that by 1.5 safety factor that's consistent with airliners. Because what other data do you have to go off of, right? Like, what else would you do? You need market analyzation when you're building a launch vehicle, because the launch vehicle provides a service, just like a airplane route, right? Oh, nice. I like that, Hard. Justin, what's that? Yeah, Europa Clipper. Maybe we should start Space News now. Why would anyone pick Falcon Heavy over SLS for Europa Clipper? Doesn't NASA know that they have a rocket which needs some missions? Well, all right. We'll get back to working on the fairing stuff here in a moment. All right. LV-5B1 forward bi-load tank. Cool. All right, let's go over here like this. I'll pop out of Kerbal for a second. And guys, I'm just going to flash the title card. We'll go right into Space News. We're already there. My big theory is that Elon is using Tesla to develop robotics tech. Battery tech, Crumpet. But it kind of is same thing. Tesla is a battery company, like an energy company, like BP or Shell, masquerading as a car company. They're using cars as a front to improve battery tech and also reduce carbon emissions. Elon mostly talks about the